the rest of them.
Fantastic.
So, yeah.
Fantastic. Welcome.
Imad, you look different.
Very much.
This is what I call it, the COVID lazy style.
I see. It looks very good.
Because under the mask, nobody recognized me. So I said, why should I shave it?
Yes, good.
Ramesh.
Fernando, you are
Hi.
taking the
Hi,
meta.
Farhan.
Hi guys.
We can't see you. Yeah.
Hey,
Matthias, good to see you again.
You are, yeah.
Nice to see
Somewhere
you.
out.
Yes, Vlad, good to see you.
Hi,
How are
Vladimir.
you, Ayman?
Hi. Hi, Matt.
So we are running the same style. They asked me about my beard. I told them this is the COVID lazy style
It is at home.
at home. Yeah, I'm putting the mask. Nobody will see it. That's
Right.
Roy, what are you doing there? Sitting alone?
The residents to turn up.
There were some.
There are some.
Kazadi, how are you doing?
Fine. How are you?
I'm fine. You are in Belgium or in
I'm
Harare?
in Belgium. I'm in Belgium, Vladimir.
Belgium, good.
Still waiting for the airlines, to be how would you call it, operational.
Right, right.
So, and things are getting a bit worse here in Belgium. So people are confining again a bit.
The same here. The same here.
Yeah.
No
So,
deaths, but more ill people. More
Yeah.
positive.
We'll see how it goes.
Yeah. Imad, how is it in Saudi?
I'm fine. Everything is okay. We have good number of registration, even without our colleague from China and Japanese, but they are joining us. I think we are coming to between 800 and 900 meantime.
Very good.
Yeah. Now,
Very popular, are we?
I received 2 calls. Dr. Boji, he will join us at 2. He is at the meeting. And Dr. Reyes, he's on a different webinar, but he will be with us tomorrow during this.
Fantastic.
Very good. Very good. Matthias, how's Argentina?
Well, here we are reaching the peak of the coronavirus. We have many cases every day. And actually, I am isolated at home because I was in contact with one of our residents that is positive for COVID. But I am fine. I am negative, but our hospital director said me, Matthias, please stay at home for 14 days. And for me, it's very difficult, but you know, for prevention.
I can tell you my parents, they are 99 and 97. They both were positive. They were confined to the infectious disease department for a month. You know, it was like a jail, but they never ever had any symptoms.
All right. 99, 90. Whoa.
99 and 97. Incredible, isn't it?
That's incredible.
Yeah, when they told me that they are positive, I thought, all right, that this is the end of it, but they are doing fine.
You seem to have the right genetics, Vlad.
Yeah.
Exactly.
Most likely. We have hundreds of these. People have nothing, you know. Just last week there was a party downtown, and they all drank some alcohol with a single straw. 120 positive people. Good party, isn't it?
Yeah, must
Yes.
Must have been fun.
Here is the same.
Was beer Corona? Was it beer Corona beer?
It was not Corona. It was. Would be fitting.
So before we start, I'm thinking, Vladimir, if you allow me, I'm going to give a small review for the people attending, give them about their feedback. How is our response? So I will take a couple of minutes on this subject.
Very good.
Yeah, because they should be aware that they send their review and the evaluation, and we'll tell them what we have adapted and what we could not adapt.
Imad?
Hey,
Hey,
Atul.
Atul.
Wonderful.
Yeah, Abdul, how are
Good
you?
to have you.
Very good, very good. Thank
Wonderful.
you, thank you. Good evening, good morning.
Glad to
Brad, what
see
do
you.
Good to
Thank
see you.
Thank you.
Wonderful to have you here, Atul.
Thank you, Imad. I
This
know
is
this is.
the vascular tree behind you, yeah?
You always have different picture. How do you do it, Atul?
That is easy, yeah?
Very simple, very simple. You know, when you start join video, you can change at that time, whatever you want from
Yeah.
your
The backyard,
Gbox.
yeah.
Uh-huh.
How are you, Imad? Everything okay?
Yeah, fine. We are waiting a few minutes, and I think at sharp 3 o'clock our time, 12 Greenwich Mean Time, we will commence. We'll
Yes.
give a short introduction, and then we will proceed. I'll leave it to the moderator, and you are one of them. And with Roy and Ramesh, they kindly having the time to be moderator with you as well.
Okay, okay.
Do you know each other, perhaps? Do you know Dr. Matthias Baldocchini from Argentina? Goel Atul from Mumbai?
No.
You might not. Dr. Kasadi, you know him? Karanjo Kasadi from Kenya, Belgium. I always give the combination.
Zimbabwe.
Zimbabwe,
Yes, yes.
sorry, Zimbabwe. And we have Ramesh Naik from England.
Yes, yes, Ramesh, how are you?
And we did have
Very good.
Dr. Martinez. He is with us from Uruguay. He is a
Here I am.
guest faculty
how are
with us
you?
today.
Hi,
He's
Victor.
presenting. And
Hi,
here's
Atul.
Victor
How are you?
from Mexico. Hi, Victor.
Yes, yes.
Hi,
Victor.
Victor.
Hi, how
Hi,
are you?
Victor.
Good
It seems
morning.
that, good morning, you are leading with the Corona, Mexico. Number one. How are you,
Victor.
Victor?
You.
Excuse me.
How
What
are
did
you?
Oh, very fine. Here in Mexico, it's okay. Still now, too many deaths by COVID. Some brain surgeons have died, but disease here is a little strong. We have almost 4,000 deaths, but we are almost 300 million people. So too many deaths, but
Here's IP. Let's have the picture of IP. IP, I didn't introduce him. Dr. Shyam from India, but he was in Nepal. He's moving back home in a different city.
yes, I know.
Yeah, I'm told, Fernandez might not know, and Matthias, you know Dr. IP, I think.
Of course,
And
Matthias.
this is not a pseudo picture behind him. This is the real. Most of us were to that place.
Yes.
And we are ready to come back again.
Anytime, guys.
Not by car.
Definitely.
Yes.
Never again by car. Hi.
The next time we'll get a chopper. We'll get a large chopper and then land in here.
And you mean parachute down?
We'll
This
chopper
is-
down. We'll have a helipad maybe on the upper property. Then we will walk down. Car is difficult even now. The rainy season, car is terrible.
I think Henry will come on the Harley Davidson on a motorcycle. Hey, hi, G.
Ramesh.
Hey, Ramesh.
Hi, hello, hello.
Hi.
Hi, Rames.
Hello, hi.
Hey,
Ramesh
Ramesh.
Corollo from
Singapore.
where's Ramesh picture?
Professor Goyal is also here right now.
I think he, yeah.
He
Madhav
is,
introducing everyone to.
yeah, I'm trying to introduce because not everybody knows everyone.
Hello, hello everyone.
Hi,
Hello,
Hey,
Frank.
can you hear me?
where are you?
Man,
I don't see you.
Oh, yeah.
Oh,
And
hey,
I'm
hi,
Felix.
hi,
Yes,
Dr. Tam,
I
how are
am
you?
corner.
Good to see you.
Hi,
Wonderful.
good to
Very
see
good.
you. Thank you for having me again. Thank you.
Yeah, now you are part of the STEM family now.
I'm very pleasure. My pleasure. Okay, out, go, out,
Great.
go. Nice
How
to
are you?
meet everyone.
Everything okay?
Yeah, I'm fine. Okay, okay, perfect. It's perfect. Yeah, in China now it's quite safe now. Yes.
Oh, yes, yes.
Maybe.
Thomas.
Everyone.
Yeah.
Thomas.
Hi, Tom. How are you?
Fine, how are you?
Fine, thank you. Good to see you here with us.
Good to see everyone.
Good to see you with us.
Yeah, yeah. So
You
do we
prepare
have,
you prepare your samples behind you on the shelves.
oh yeah, yeah, that just dry. Yeah. Do we have everyone for the talks today?
Sorry, I didn't get you. You have?
Do we have everyone for today?
Yes. So in a few minutes, I will commence to give an introduction about the previous webinars and then with some housekeeping items that will make it clear before we start. So we'll avoid interruption and noise.
You mean like fire exits and
Yeah. Yeah, that's correct. Not somebody coming from the OR say, oh, hi, come leave the room and we need you. I don't see Pablo because Pablo was here.
Pablo is here.
I'm here. I'm here.
Pablo and Sanjeeva is not there.
Can't see him.
Sanjeev perhaps is coming tomorrow. I don't know. He's not on the schedule for today. Well, I think are we on time now? Is it 3? Is it 12?
Well, almost 2 minutes more, I think.
Two more. Yeah, I agree. Let's wait. So Atul, I have the first picture we met with Dr. Fukushima in Japan.
You have it?
That's 90, I think 1991 or 92.
1991, yes.
91. With Professor Kos and Banensky.
Yes.
God bless his soul, both of them.
And Fabian Isamat. You remember Fabian Isamat?
Yeah, Fabian was there. Yeah.
He's a Spanish neurosurgeon who was doing cavernous sinus fistula by direct implantation of muscle inside the cavernous sinus.
Yes.
Fabian Isamat, very famous during that time.
Sure.
Spanish neurosurgeon. He was a young man at that time. Like
Instrumental
you and me.
in a European association.
We were babies.
And also Kuz, you remember? He was with us.
Yeah, Professor Kos, yeah, from
Yes,
Vienna.
Yeah. Yes.
Kos from Vienna. And there was somebody from Bristol.
No, there was this person, Parneski. Parneski was with us.
Parneski was there, but from Bristol was a famous guy who did a lot of the vascular decompression. Alan something. Yeah.
So we are almost done. Vlad?
Okay, we are going to start. Good day for everybody. I thought the wording from Australia fit the best for East, West, North, and South. And on behalf of the World Federation of Neuroanatomy Committee, Professor Vladimir Benish and myself would like to welcome all the attendees and the faculties. A few housekeeping issues. I'd like all the faculty to mute their microphone and cell phone during the presentation of their colleagues so there won't be interference. Please use the icon, raise the hand if you have questions, so the moderator will take care of that in the sequence. And for the attendees, they can put it on chat, their questions, and the moderator will try to answer, select some of them, and the one cannot be answered live, the speaker, he will take care of that later on at his ease. This is very important. The presentation will be 20 minutes sharp, including any videos, and we leave 5 minutes for discussion. Of course, the 5 minutes was the major complaint, is little, but for the time being, we'll continue on the same things regimen, so we'll finish on time rather than too late. Today we have 7 lectures. We have 3 moderators. I'm going to present them shortly, but I'd like to give a feedback about the 2 previous webinars for the audience so they understand. We reviewed their feedback. We appreciate their feedback. We received 970 respondents for the second webinars. And these are a few of the things I would like to share with. First, the format, 92%, they appreciate the format. There is always outlier that they'd like to have it differently. They like to have 1 topics and 2 lecturers only. Everyone has his wishful list, but we cannot follow this, understandable. The different level of training and expertise make the depth of the presentation different, because we ask about the depth, how they feel the depth of presentation fit their qualification or not. And the typical response, the experienced people, they found it fit 100%. The intermediate in training and the advanced years, they like it very much. The beginner, they found it a little bit advanced. We'd like to cater for the 3 groups. So that's why I said we'll keep the design the same, because we are not going to give a neuroanatomy as a basic science, but we are going to give it as a progression to clinical practice. And they should be aware of the simplest and the advanced. It depends on their level. And 92% agree to this format. So we'll continue on the same format. The other things, the timing, 12 Greenwich Mean Time, I think this is the best timing. If you want to change or deviate from that time, you will affect some groups in some countries. If you make it later in the day, it will be after midnight in China and Indonesia. If you do it earlier, it will be 4 o'clock in US and North America. Of course, there are their webinars, but we are trying to be appropriate. Whoever wants to attend, he should be waking up at 9 o'clock and attend if he wants. And we don't know the future, because we don't know if the whole COVID finished, we might revert back, but it looks like this is the trend of education. We'll keep it. But I think going back to work, and the juniors especially, they will be in the OR or in the clinics. So they might not be able to attend, and we might adjust the time accordingly. So we are not rigid, but at this moment, we will continue the same. The other thing, there was a question about repeating some of the presentation in the same session. It has some reason. We don't do that often, but it has a reason that will give a feedback from a different perspective, different experience perspective. Some do this in this way, and the other one, the same session, you do it in different way. So it gives an idea of the different approaches. So you adapt whatever is convenient for you, your setup, your tools, your expertise. You need to advance your knowledge. You go and visit some masters, or you attend some masters in their practice. But it has a reason. We are not by mistake, we did that, duplicate the title, okay? So it has its value, and it has the drawback as well. There were, I wrote something here. There are a few topics requested. Some of them not related at all to neuroanatomy. We cannot have a pure, like somebody asked about research. Research, it will be during the presentation. There are dedicated webinars for research. You can attend it for research methodology and all these things. You can read about it. But this committee has a mandate. It's the progression, as I said, from a neuroanatomy to clinical practice. This is the combination we are trying to do, and I hope we are doing a good job with this. Some of the subjects they are not related, and I don't like, and I'm sure you agree, to do a trivial job by encroaching on somebody's webinars. They are doing a great job with it. So they should attend these webinars they are interested in. But we are, the promise, we are collaborating with other World Federation committees to do some joint venture like the spine or the functional. We might bring them in a half-day session or one-day session to collaborate with them on issues that has a neuroanatomy and clinical values. As I said, today is the we are focusing on intrinsic brain tumors. There were several presentations submitted for this purpose. And that's why we selected the topics, and it's worth. And the other day will be purely on intraventricular anatomy and intervention. So for today's moderator, we have, of course, our visiting colleague, our guest, Brother Atul Goel. It doesn't need introduction. He made us his name in many aspects and publication years ago, not only on the spine, because everyone pointed to the neck when I talked to Atul names, but I know him very well from the skull base committee meeting, from the vascular. He has contributed to many aspects. He will be co-moderating with my two brothers, Dr. Thomas and Dr. Ramesh. Both are from England, and I think Thomas will lead, and then they can divide the moderation according to their convenience. I leave at this stage, and unless I ask Dr. Professor Vladimir if he wants to add anything additional to this webinar contribution.
I don't need to add too much. I just would like to point out that this is a tremendous effort and amount of work of Imad, who did extraordinary job, and that I believe that I'm not talking on behalf of all the other committee members, that we really appreciate the work and we enjoy your company, and we enjoy to be with you.
Thank you. Without you, we could not do it. I have to add that the work of Pablo Gonzalez, he is the dynamo of this committee, because most of the logistic, he has done it, and I appreciate that very much. And of course, we have Igor. He is excusing himself today. He is the secretary of this committee. And Dr. Sanjeeva has contributed as well to the feedback from the audience. So thanks to all of you. And we are going to alternate seats on this functionality with a moderating, a presentation. So everyone will have his share. And we would like to always to add one or two international speakers here. Dr. Atul I mentioned, and Dr. Martinez is coming from Colombia, I think, or yeah,
Uruguay.
He's with us. Uruguay. Uruguay. Yeah, he's a neurosurgeon with deep interest in neuroanatomy, and he will present today as a guest faculty. Thank you. I leave it to Tom. Roy, actually. Roy is the moderator today. Yeah, sorry. Roy, I am so sorry. I'm seeing with your team. Roy, he is from Switzerland. He is a co-chair there, and he is a major contribution to this committees. And I'd like him to lead the moderation of this session with Dr. Atul and Dr. Ramesh. Thank you.
I think it's with Victor, Imad.
Is it Victor today?
Okay, so what I'll do is, whilst we are waiting for Dr. Roy, let me begin the show. Let me begin the journey of 2 days of anatomy. Anatomy forms the basis of our subject. As good as your anatomy is, as good your surgery will be. You have to dedicate a lifetime in anatomy if you have to become a lifetime neurosurgeon. There is no way out. Neurosurgery and anatomy go very parallel. And I'm here to learn what very fantastic and very famous anatomists and surgeons of our times will demonstrate to us today and tomorrow. And I hope and I wish that all the young people and all the more senior people learn, enjoy, and try to emulate by dissection, by going to the cadaver lab. I will like to tell you one thing before we begin. You cannot learn anatomy by sitting on computers. You have to go to the cadaver lab and study anatomy. It is like enjoying your partner or your friend by virtue of phones or by photograph. You can never enjoy that partnership. You have to touch, you have to feel, you have to love, and you have to enjoy. Let us love anatomy and let us go further for our 2 days. So we begin with Pablo. Pablo is a young Spanish neurosurgeon who is a fantastic anatomist and an emerging power in the world of neurosurgery. I have been very deeply impressed by all the work that he's doing and all the fantastic anatomical correlation with surgical techniques that he's showing on several webinars throughout the world. And I'm sure all the people in the audience will love to listen to this emerging giant of neurosurgery. Pablo, here you go. Pablo.
Wow, thank you. I hope this is recorded. So let me start sharing my screen because I will start. You know if you can you see my screen?
Yes.
So we decided, Ima decided to start with this suggestion, which is the first lecture for today. And this is a kind of review of how our central nervous system has been developed and how understanding that and understanding the anatomy, we can take some points that will be really, really useful for our surgical approaches. And let me try to convince you about this. So how to define a central nervous system? So the thing is that it could be defined as an organized group of one or more cells specialized for the conduction of electrochemical stimuli from sensory receptors through a network, very complex in our case, to the site at which a response occurs. But as you can see in the video, we need a modulator, which is part of that circuit. So we need a receptor, effector, and that circuit which has also a modulator. And from that complex definition, let's go to the first central nervous system. This is a bacteria. So I'm gonna try to summarize in 20 minutes what has happened in 3.8 billion years of evolution. So how we can go from this state to this complex central nervous system. So mainly there are three important aspects: mutations, the environment, and the need that every human being, every life animal has, survival stress. So we need to survive. So all these things intermingled are the ones who are developing the changes that will appear in our central nervous system. What and how do we know about this evolution? So we can have a look at the fossils, molecular studies, endocasts, contemporary species. We can learn also how they are evolving. But the most important thing is to have a look at the embryology. And the first one who did this work was this guy, this funny guy, Ernst Haeckel, who wrote the theory of recapitulation. And his main state was that the ontogeny recapitulates the phylogeny, which means that every single change that we will observe in the embryos will be the reflect of what happened during the phylogenetic evolution. And this is very simplistic. Let's be honest with ourselves. The development stages will recapitulate in the adult evolutionary stages. So this is what he was stating. So we have the evolution of a fish from the egg to the adult, and then he is defending then the frog will have exactly the same evolution and then some changes being added. And the same thing with the birds and mammals and so on. But if we have a look at the embryology and the mutations, we will realize that this is not possible. So let's have a look at these two embryos, these two fishes. One of them is going to develop in an adult fish, but the other one will suffer a mutation in an intermediate stage of the evolution. So this mutation will consist on the transformation from fins to what we have, limbs. So it will give rise to an amphibia. And if you have a look at this, we will share, the fish and the amphibia will share only the early stages of the evolution, but these ones will be completely different. So this is what is really happening with the evolution of the species. The embryo's development only recapitulates premutational stages, increasing the biodiversity. So this simplistic linear evolutive process is not correct, and what we usually can observe in the evolution is this fantastic cladogram. So this is the key for the biodiversity we do have nowadays on the Earth. But how we can understand this 500 million years evolution from this very simplistic central nervous system in the fishes to our very complex central nervous system. So if we have a look at the genes, we will realize that the prosencephalon, the hindbrain, the forebrain, the midbrain, all of them are the same or almost the same in both central nervous systems. But there are some very important changes that will appear during this evolution. So if we have a look at this coronal cut of the human central nervous system, we will see the cortex, the so-called pallium, because it's covering the underlying cerebral substance, which is divided in white matter and gray matter. And let's concentrate mainly on the cortex, how the cortex has been evolving during these 500 million years. The most rudimentary central nervous system, the central nervous system of the fishes, it's mainly covered by 1 or 2 layers of neurons, very simple connections between them. So this is the primordial pallium, the paleopallium, the very old pallium. Almost 100 million years later, we have the so-called archipallium, which is quite complex, 3 to 4 to 5 layers of neurons, and is mainly located, as you can see, just medial to this paleopallium. This is mainly located in the amphibia. Some reptiles, once this genetic change appeared that I just showed you, these reptiles are developing not only this archipallium and the paleopallium, but also the so-called subpallium. This subpallium is located, this gray matter is located in the central nervous system, in the middle of the central nervous system. This is gonna be the rudiment of the basal ganglia, because these reptiles needed to coordinate perfectly their movements because they don't have fins, they have limbs, so they have to walk and sometimes they have to run. But probably the most important phylogenetic change appeared when the neopallium appeared in the first mammals, the paleo mammals. This is the primordial neopallium. And this neopallium is composed mainly by 6 layers of neurons, very complex relationships in between them. And this is finally going to give rise to the neopallium, the neocortex, all the mammals we do have. And the most complex central nervous system of the mammals, it's requiring of a huge development of this neopallium. And due to the conflict of space, this flat surface is becoming in the so-called sulcogyral pattern. So this is why we have all these changes in our central nervous system. So we can identify the paleopallium, mainly located in the brainstem, the amygdala, and the olfactory cortex, also some of them in the insular lobe, in the lumen insula, and it's mainly the old brain done for survival issues, mainly a short memory and differentiation in between fear and danger. Then we do have the archipallial regions, which are mainly located in the so-called limbic and paralimbic areas, as you can see. So cingulate, parahippocampal gyri, the fornix, and also at the level of the insula. The subpallium, as we said before, is mainly located at the level of the basal ganglia, and it's very important to coordinate our movements and other functions in the neomammals. And we can have a look at these paleomammals we were talking about. So mainly these ones, we have a mainly limbic brain based on emotions. However, if we have a look at our human brain, we will have most of the 90% of the surface covered by neocortex, this neopallium, which is the one which is giving us the rational thinking. So very complex functions on them. So is it important, the size? So it is. And we can see how the more cephalic mammals are located above this line. And let's have a look at the man and rhesus monkeys. So why we do have bigger brains? Mainly because we need to regulate our internal temperature. And most importantly, we are dependent on acquired processes. We are less dependent on the instinct as the previous animals we were discussing. And when this happen, so you can see how our skull is much bigger compared to the skull of the paleo mammals. So this is because these primates were mainly using their masticatory apparatus, which is very, very big. And there was a mutation 2.5 million years ago. And this protein, which is only appearing in the masticatory muscles of these primates, completely disappeared. So this very, very strong muscle, which is attached to the sagittal crest, as you can see, disappeared. So this is why our sutures were able to continue growing during the first stages of our development. And this gave rise to a bigger volume of our brain and to a smaller volume of our masticatory apparatus, which also changed the pharyngeal shape. So this is why our voice is much more clear than the voice of this animal. So you can see the tremendous increase of volume of this central nervous system. And this coincided with the capability of hunting, harvesting, and cooking. So everything is completely connected: environment, survival, stress, and mutations. So you can see the difference in volume in between a chimpanzee and a human brain. And the most important thing is to understand, seeing these graphs, that it's not only because of the growing of the neocortex. Indeed, it's because of the new development of the connections of these neurons. So this complex layer of 6 layers of neurons in the neopallium is giving rise to have a large amount of connections, the white matter. And the most important white matter fibers we are having, and it's a big difference with the primates, is the ones called association fibers. So these are the ones who are really important. We can have a look now at all these changes in our human brain, and this is a nice concept I took from Professor Balavanis and Professor Yazarhil. If we trace this imaginary line in between the cingulate sulcus, superior peninsular, inferior peninsular, and collateral sulci, we will see this so-called phylogenetic barrier in between the old brain and the new brain. And there are some issues, there are some theories that tumors on both sides of this phylogenetic limit are behaving in a different way. Let me show you this small tumor of this 18 months old baby who came with scissors to our clinic, a very, very bad controlled scissors. You can see how this tumor is mainly growing in the temporomesial pole, 1A, defined by Professor Yazarhil, in the head of the hippocampus, which is hidden right there, and into the amygdala, which is just in between the temporal pole and the hippocampus. It's an extraventricular structure. So in these 3 regions, this tumor is growing. So if we attack this tumor from the lateral aspect, it's very important to consider the location of Meyer's loop. This is why in these cases, we like to go quite polar, quite anteriorly, open a little bit the sylvian fissure, and to do what we call the transplanum polare approach. So we are releasing CSF at the level of the cistern right there. And then in the most anterior aspect of T1, we start our transplanum polare approach, and we will reach this temporomesial region. This is the temporal pole. So just lateral to the lateral wall of the cavernous sinus. Now we are moving posteriorly to the amygdala, and finally to the head of the hippocampus. So Meyer's loop is quite superior. This is the tentorial incisura, and this is the 3rd nerve. So once we see this pia and we do this pia resection, it means that we have finished, we have reached the most lateral, the most medial part of this tumor. So this is a limbic tumor, very, very characteristic limbic tumor in the amygdala and in the head of the hippocampus. And it's behaving like a low-grade glioma, which is what it was. And the lady is free of scissors now for 7 years. Let's go to a different area. And first of all, let's introduce some concept, these gliomas growing patterns introduced by Professor Yasser Hill. So the gliomas are supposed to grow in the subcortical aspect, and most of them will grow in the direction of the ventricular system. Let's have a look at this low-grade glioma, which probably converted into a high grade, and we found some blood on it. And this patient started, he was 12 years old when he came to our emergency room, saying that suddenly he felt some loss of strength in the contralateral hemibody, and in 2 days during the study, he got completely hemiplegic. So this tumor was growing and pushing the corticospinal fibers because it was growing mainly in the pre and post central regions. So in this case, this is a neocortical tumor. The growing of this tumor is directed to the ventricular system. So this is how we have to plan this surgery. This is the postcentral gyrus. So now we will try to do a functional resection, looking for the response of those blue fibers which were pushed anteriorly. In the lateral aspect, we found them there. We check that the corticospinal tract is working properly. And this is the depth of the central sulcus. So we start, it's quite surprising that there was no function there, but you can see how this glioma was growing in that region. And this is the so-called functional resection. So we are looking for the response in the most anterior part. So doing this functional resection, it's unbelievable that we could do this resection, but the patient after 6 months was completely neurologically intact. He has some loss of strength in the most distal part of his left foot, but he's doing quite nice. So that was the initial growing pattern. But in the intermediate growing stage, these gliomas are using those fibers, not only pushing them and displacing them, but also using them in order to grow. And if we leave those tumors growing, then we will have the advanced growing stage. And this is a terrible one in which we will have symptoms, very uncomfortable ones, because these gliomas, high-grade gliomas, will start destroying these fibers. So let's go for this case. Look at this scan, October 2019, 53 years old man. He came to our clinic 2 weeks ago, and I will show you what has been happening. Because in October 2019, some memory loss, and it was decided to follow up this tumor. You can see that the tumor, this is a purely hippocampal tumor, located only in the hippocampus, head and body of the hippocampus. You can see this image, it's equal. So the tumor is very, very well located in this limbic region. But then a follow-up was decided, and 6 months later, you can see that the tumor is still there, but it's much bigger, double size. And I don't know why it took so much time, but we saw him 3 weeks ago in the clinic, and look at what happened. This is the evolution of a low-grade glioma. Now it's a glioblastoma. And in this case, we did the surgery last Tuesday, 1 week ago. We decided to try to attack the tumor from the most cortical part, trying to avoid the left temporal lobe. So this is why we went from a paramedial supracerebral transtentorial approach to try to enter the atrium from the floor. And I took this from Professor Ture, who is a real expert on this kind of approaches. So this is the left suboccipital craniotomy. We release some CSF from the cistern and we place this cotonoid. So during the surgery, we can have some dynamic release of CSF whenever it's needed. We place this small cotonoid, and with the ultrasound, we try to check the point in which the tumor is more cortical, somewhere near here. So once it's clear, we cut the tent, we coagulate, we try to avoid these big venous lakes, and then we cut the tent in a L shape. I learned this from Vladimir Benes. This is very, very nice because you will gain a lot of space. And this is the parahippocampal gyrus. And now we are going inside and directly we are in the tumor. So that's the GVM. Finally, it was a GVM, very, very bad one with an 80% of Ki67 marker. So very, very ugly one. We did a resection. This is the choroid plexus, but we couldn't take completely that tumor because the most anterior and medial part was hidden in this field. So this is the choroid plexus, that's the midbrain, and this is the resection we were able to do, and we were not able to take this more mesial part. Well, let's go to this case. This is a young man. This is a neocortical tumor, different one. It was a pleomorphic astrocytoma growing in a very close relationship with the arcuate and the optic radiations. So in the first stage, we do the cortical mapping to decide where to go through in the cortex. Then we check the arcuate fascicle subcortically, and we can see the difference on tissue. It's very different, the tumor to the tissue. And once we found the speech arrest, we stopped. And the last thing we want to do is to do an intraoperative campimetry. And for that, what we are doing is we're showing the patient this video, and he can draw in this screen while we are stimulating the depth, so we can see how the fibers of the optic radiations have been pushed into this tumor. Because pleomorphic astrocytoma usually are non-very invasive tumors, so generally in the first stages they start displacing these fibers. Indeed, the patient was neurologically intact. You can see after the stimulation how the patient is drawing this deficit in the inferior lateral quadrant. Then we move to the posterior aspect of the surgical cavity, and he's drawing a different deficit. So once we are stimulating the optic radiations, the patient is experiencing some blurry vision or many shadows. So it's indeed, it's not a stimulation, it's a negative stimulation, what we are doing. And with these two combination of stimulation in the subcortical aspect, we were able to achieve a very nice resection with a small campimetric defect in that region, which is not a problem. And this is the last case I want to show you. And this is what started being the sad story of Lady B. This lady, she was a scientist 17 years ago. And during one of her experiments, she accidentally drank some drug, and she had a big problem in her retina. So she was completely blind for 17 years. And this is a fantastic project which started in Utah and in our university here in Alicante. And what we are trying to do is we are trying to reach this layer 4C of the pyramidal cells into the occipital cortex. So we are trying to jump all these optic radiations because the problem was in the retina, and we want to stimulate this layer. This layer is mainly connected to the lateral geniculate nucleus. So this is the one we want to stimulate. But there are some other layers, and these all other layers of the visual cortex are interconnected with different lobes of the human brain. And this is the project. This is the fantastic team, the bioengineering department. I joined them 5 years ago for this and other projects. And the idea was to implant these very, very thin electrodes, 100 poles, into the layer 4C, because we want to stimulate only those neurons which are connected to the lateral geniculate nucleus. So this is where we place that electrode. This is how we are placing it in the cortex, in the occipital secondary visual area. And the first intraoperative recordings were fantastic. So you can see how more of these poles are getting potential actions, very, very nice ones. After surgery, we tried to stimulate all these poles. So what we are doing is just the opposite to what we were doing when stimulating the optic radiations. This is not a negative stimulation, this is a positive one. So we are trying to train this lady, and it took like 3 to 4 months to train her completely. And this is a clinical trial, so we had to take this electrode 6 months later, but we had time enough, and she was fantastic. So you can see after 3 months, she was able to identify black and white with a camera, which was directly connected to a computer and then to the electrode. It's a handmade procedure, what this fantastic team is doing. And she was able to differentiate and to identify, looking at the visual field, where the black dots were appearing. And this day was very, very special. She was very, very keen to tell me that this was a big step on her evolution, because by the first time she was able to differentiate between light and dark, which is very important for blind people. So that's all. I hope I'm on time. I didn't bore you too much, and I just wanted to conclude saying that this is not the sad story of Lady B. This is the great story of Lady B, and identifying and understanding all this evolution, identifying, understanding how the connections in our brain are made and how the functions are working, how important is the white matter, and then applying technology can lead us to a fantastic result with a big interaction with our patients. Thank you so much.
Thank you, Pablo, very fantastic presentation as usual. And on behalf of Roy, Daniel, and Victor, you want to say something? Whilst Victor is preparing, I will like to make a few comments, Pablo. One is you said beautifully about the evolution of the brain. Archicerebellum, paleocerebellum, cerebrum, neocerebrum. And that is why the whole combination of these three systems in the temporal brain makes it more vulnerable to epilepsy, because there is so much confusion in the temporal brain. Because all this developmental layers of the brain are located in the temporal brain, like in the limbic system, in the paralimbic system. That is why there is more epilepsy. The other thing that I heard from your lecture was a beautiful thing to remove the tumor, amygdala hippocampectomy, that region from the supracerebellar root, transtentorial supracerebellar root. That was quite interesting to see that tumor. But I will just like to tell you that the first tumor resected, middle fossa tumor resected by the posterior fossa root. Do you know when and who resected first? A tumor. No, you don't know. Yeah, so we removed first tumor from the posterior fossa root in the middle fossa epidermoid. That was a simpler tumor, but that was the first time it was removed. After that, there has been many tumors, like amygdala hippocampectomy has been done. Then parahippocampal tumors that you have shown, Hugo Toure has been quite, popularizing this supracerebellar root. He has been quite good. And there are several other groups doing this supracerebellar root. So these are the two things which I enjoyed. Of course, what we have to learn is the development, embryological development, the beauty of the brain. Did you realize, Pablo, that the sulci and gyri are discrete? Every human being has different pattern of sulci and gyri. They are like fingerprints. You put your finger, the print is different. Similarly, the sulci and gyri of every human being is different. That is the beauty of the nature. And that is the beauty of the development. And also you said one beautiful thing as to how from one cell, you see, when the sperm and ovum grows, they become together, they make a zygote. So there is a new cell formation. From this cell, how the development grows from one animal to another animal, there can be no mistake in this development. And how from one cell to 13 trillion human cells are made. So this development of human body is such a miracle, and we have to love to enjoy to see this miracle of God, that how this development occurs, and there is no fool. This is foolproof development. So this is what I have to say.
Thank you.
Otherwise, Pablo, there is no question on the screen I can see. Otherwise, I would have put that question. Victor, you want to say something? And Roy, Daniel? I don't see them on the screen somehow.
They are there. I can see Roy.
Okay.
I can see Victor.
Okay. Congrats, dear friend Pablo. It's not easy to manage ontogenic, phylogenetic, and also to mix with clinic and surgery in 20 minutes. You did it very well as a real master. Really, really, congratulations. A very nice conference. Thank you so much.
So with this lecture where you said that structural innovations are the functional necessity of the animal, are the basis of structural innovations that the body makes, from lower animals to higher animals, from a monkey to human being, from a whale to human being. Structural, what is the functional necessity and the structural innovations God makes? So this was a beautiful presentation by a very handsome Pablo. And I think it is time to move on to the next presentation. also from one very emerging young star from Uruguay, Martinez. And I have seen, Martinez, some of your beautiful dissections and some of your beautiful anatomical work. And I must say your anatomical work is amongst the best anatomical work that I have seen ever in any kind of literature. And I am very eagerly looking forward to your presentation. Fernando Martinez.
Thank you very much, Atul. Thank you very much, Professor Imad Khan, for the invitation, and also Pablo for the organization of this webinar. You must habilitate me to share my screen, please.
Can you try now, Fernando? Now it's open.
Okay.
Perfect.
Okay. Can you see the screen?
Perfectly.
Okay. This lecture, I think, is more for residents than for neurosurgeons. I will speak some topics about white matter substance, and also I will try to do a correlation between anatomy and imaginology. This is my country, located here in South America, between our two giants neighbors, Brazil and Argentina. Well, why study the white matter tracts? When I was a resident, all of my professors told me, be careful with Broca area, be careful with Wernicke area, be careful with primary motor area, and also the cortical tract, and maybe the optic radiation. But we have to respect all of white matter tracts, because when we perform a cortical lesion or a cortical resection, we can trust in cortical plasticity. But if we damage the white matter tracts, we have no plasticity. So we have to change our paradigm from localizationism, cortical representation, cortical areas. We have to respect, obviously, cortical areas, but we also have to respect the white matter tracts that connect the cortical areas. That means odotopy. Odotopy is a Roman word that means way. So we will start a short trip to the white substance, but especially for the white matter tracts implicated in language functions. And I will speak shortly about some tracts in the view of functional anatomy. So we will review the origin, the trajectory, the relationships, the termination, and also the functional anatomy of some tracts. As Pablo told us first, we can classify the white matter tracts in three categories: association fibers that connect different areas of the same hemisphere. Here we can see the IFOF, the origin of the inferior frontal occipital fascicle, running from the frontal lobe to the occipital lobe. This is an association tract. Second, we have the projection fibers that takes its origin in the cortex and travel outside the brain to the brainstem, cerebellum, and spinal cord. And also we have the commissural tract that connects both hemispheres. I will speak today about some association tracts related to language. So these are all of the association fibers that we can find in the brain. I will speak shortly about some of them. First of all, the U fibers. This is a right hemisphere. Here we have a convolution, another convolution, a sulcus, and in this region, I have dissected the cortex, and here we have the white matter of one convolution, the white matter of another convolution, and the depth of the sulcus. Here we can identify the U fibers, the white matter connecting one convolution with another convolution. This is the orbital part of the inferior frontal gyrus. This is the triangular part and opercular part. We can also identify the same thing here. One convolution, the white matter of one convolution, white matter, and the U fibers here. Here we can clearly identify that fibers running from one convolution to another, connecting neighbor convolution. The U fibers are short association fibers. And look at this. This is one convolution, a sulcus, the depth of the sulcus. And this is another convolution. Look at this. In this region, in the center of the convolution, we have the long association tracts and the projection fibers. And in the lateral part of the convolution, we have the short association fibers. So if we need to reach that lesion, for example, we can choose two ways: transcortical approach and transsulcal approach. If we choose cortical approach, we will damage the projection fibers and the long association fibers. And if we choose the transsulcal approach, we will damage only the short U fibers, the short association fibers. This is the correlation, the imagenological correlation. The U fibers connecting two convolutions. And here, the U fibers connecting F1 to F2. Here is the sulcus, the depth of the sulcus, and the U fibers. This is my city, Montevideo. Second, the frontal aslant tract, or FAT. This is a recently described fascicle described in 2012 by Marco Catani and his group. But in the literature, there are some publications that describe a similar tract in 2008. The FAT is like a long U fiber. Look, this is the original description of Catani. This is F1, F2, F3. The short U fibers make this, and the frontal aslant tract make this from F1 to F3, connecting Broca's area with F1, especially the supplementary motor area and the pre-supplementary motor area. So the frontal aslant tract participates in the left hemisphere in language tasks and in the right hemispheres in executive tasks. This is an anatomical specimen dissected by Veronica de los Santos. This is a left hemisphere. Here is the white matter of F3, sorry. This is the white matter of F2, and this is the white matter of F1. We can see that fibers running from F3 to F1 in the area of the pre-supplementary motor area, running behind F2. And this is the tractography. This is F1, F2, F3, and that fibers connecting F3 to F1. If we need to resect a lesion here and we choose the transsulcal approach, maybe we can damage this tract and the patient will have an aphasia. So if we respect broadcast area, but with damage the frontal ascending tract, the patient will have an aphasia. This is also an original publication of Catani with the fat, and this is the location of this tract in the frontal lobe connecting F3 with F1. Next, we will see the superior longitudinal fasciculus and arcuate fasciculus, but we will see together because some researchers consider these two tracts as a part of the same fiber bundle. Why? Because they are related to language functions, but not also functions, language functions. So the superior longitudinal fasciculus has 4 parts that connects frontal to parietal lobes and frontal to temporal lobes. The first parts run from frontal lobe to supramarginal gyrus and is related with language functions. The second part runs from frontal lobe to angularis gyrus and is related to visuospatial memory. The third part runs from frontal to precuneus region and is related mainly with working memory. These two functions are mainly located in the right hemisphere. And the fourth part, the parieto-temporal bundle, are related with phonological process, mainly in the right hemisphere. So these two bundles are located here in the depth of F2, running from frontal to parietal lobe and running from parietal to posterior temporal lobe. This is the bundle of superior longitudinal fasciculus and arcuate fasciculus. This is the location deep to F2. And this is a white matter dissection of these tracts. We can see here the fibers running from frontal to parietal lobe. And we can see here the fibers running from parietal to posterior temporal lobe, running above the insula. This is the insula. We take all of the cortex from frontal, temporal, occipital, and temporal lobe, and we can identify the anterior insular sulcus, superior insular sulcus, and inferior insular sulcus. So we can identify superior longitudinal fasciculus running above the insula and depth to F2. Another specimen, this is the superior and arcuate fasciculus. This is the lenticular nuclei, and these are the fibers of the external capsule. This is the uncinate fasciculus running depth to the insula, the limen insulae. This is another specimen. This is not so beautiful, but we can identify clearly the fibers of the superior longitudinal fasciculus and arcuate. We can identify here the uncinate fasciculus, fibers of the IFOF running above the temporal ventricle, and the fibers of external capsule. And we can also identify here the insula, anterior, inferior, superior sulcus. This is the area in which can locate F3, F1, and the white matter of F2. And we can identify clearly in this tractography the fibers of the arcuate longitudinal fasciculus. So the anatomical specimen and the tractographic correlation. So let's see now these three fiber bundles, the IFOF, the inferior longitudinal fasciculus or ELF, and the uncinate fasciculus. And why we can see these fascicles together? Because they form a bundle related with language functions specifically, and we can identify two streams in language pathways. The phonological dorsal stream, composed by superior longitudinal fasciculus and arcuate fasciculus. So we study these two fasciculus together. And an ventral inferior semantic stream composed by the IFOF, the inferior longitudinal fasciculus, and the uncinate fasciculus. And we can also identify in the ventral stream the IFOF as the primary pathway for language, and the uncinate and inferior longitudinal accessory fasciculus as an accessory pathway to language. Look at this specimen. We take all of the cortex. Here is the lenticular fasciculus, fibers running to the internal capsule, temporal lobe, frontal lobe, and the fibers of here of uncinate fasciculus, the fibers of the IFOF running in the limen insulae, and we can identify clearly the fibers of the inferior frontal fasciculus that is located here. So we can identify the primary way, the primary pathway, IFOF here, and the accessory language pathway formed by the uncinate and inferior longitudinal fasciculus. In this specimen, we can identify clearly the uncinate fasciculus here. This is the temporal lobe, frontal lobe. Here is resected the lenticular nucleus, and we can see here the fibers of the internal capsule. And here we clearly identify fibers connecting frontal lobe with temporal lobe. This is another specimen. We can identify here frontal lobe, temporal lobe, limen insulae, lenticular nucleus, olfactory tract, and here we can clearly identify these fibers running from frontal to temporal lobe. These fibers here, inferior longitudinal fasciculus, and clearly also these fibers running from frontal to temporo-occipital lobe, running in the area of the limen insulae and related with the temporal ventricle. Here again, the uncinate fasciculus and the correlation with tractography. The uncinate fasciculus running from frontal in the limen insulae to the temporal lobe, and also we can identify here fibers of the inferior longitudinal fasciculus. This is another anatomical specimen. Here the IFOF. We can see clearly the IFOF here, here, and here. This is related with the language functions. This is a detailed view. The lenticular nucleus was resected, the limen insulae, and here fibers of the IFOF. The IFOF is located in the depth of T2 in relationship with the temporal ventricle. We have to respect this pathway if we need to respect the language functions. And this is a tractography when we can identify fibers from frontal to temporal lobe, fibers from frontal to occipital lobe, that mean uncinate fasciculus, the IFOF here, and small fibers of the inferior longitudinal fasciculus here. So the correlation between anatomy and tractography. Here, uncinate fasciculus, uncinate fasciculus. Here, the fibers of the inferior longitudinal fasciculus. We can identify the fibers here. And finally, the fibers of the IFOF running in the limen insulae in relationship with temporal ventricle running until the occipital lobe. We can identify the fibers here in this bundle. So I have only 20 minutes to speak about white matter tracts. My goal was to show you these tracts related with language. So thank you very much for the invitation. Thank you, Imad, and thank you, Pablo. I'm sorry because I am not a native English speaker, so I have a limited language to speak with you. I'm very sorry.
Thank you. Fantastic. You see, I will congratulate Professor Imad Kanan and Vlad for organizing this fantastic anatomical show for the young people. You see, I see more than 350 people on the panel, and I am sure all these young people must be enjoying. And Martinez, very beautiful teacher, fantastic teaching of these fiber tracts and how one tract goes from this side to that side and how you can damage. You work here and you damage this function on the other side and remote damage. So all these things are so important when we are doing interaxial tumor surgery. I think Fernando, beautiful. I really enjoyed, and I wish that all the young people who have learned from this lecture should go and do some dissection. And Fernando, next time you must, show how this dissection has to be done. Roy, you have any comment to make? And Victor?
Well, there is a question of Ahmed Sharif. He's asking, in a resection of a tumor, how we can discriminate pathological tissue from surrounding white matter tract fibers. How differentiate the tumor from white tract fibers?
Okay. For me, the response is you have to make an awake surgery. There is no anatomical way to identify the fibers, but there is a functional way to identify the fibers. Actually, I perform in my hospital awake surgery to identify all of the tracts, white matter tracts related with language. If you stimulate, you can identify function, so you identify the white matter tracts.
Thank you,
Okay.
Fernando.
Yeah, thank you.
Thank you so much. Nice lecture.
Thank you very much.
Ibrahim, you want to say something?
Yes, indeed. It's a great pleasure to see you all, and I just want to reiterate what Atul Gol said, that as a surgeon, you are good as your anatomy is. And from that point, this is a call for the senior neurosurgeons to impose on their young trainees that they will be asked a lot of the questions of anatomy in the exam. And it's a call for the young neurosurgeons and residents to go and read for the anatomy. When they know that they will be asked this in the exam, they will have to read, because we can ask them about pathology and we can ask them about radiology, but the most important segment of their training is anatomy. And if they know that 50% of the questions would be about anatomy, they will go and read it. There is a Greenberg book that people believe that this is a textbook for anatomy or textbook for neurosurgery, but I'm saying that it is not. As you said, Atul, they have to go and read anatomy from the anatomy books, and they have to go for cadaveric lab to learn how to do the surgery by learning the anatomy. So I'm just reiterating what you have said about the value of anatomy.
Thank you, Ibrahim. Now,
Thank you very much.
I invite Thomas Santarius from Cambridge University. Thomas, you have a difficult task with Fernando's lecture and Pablo's lecture, but I know that you will not only do justice, but you will just rock it. And I wish you my best wishes. Thomas Santarius will talk on insular region surgery. Thomas.
Thank you very much, Professor Goel. No pressure whatsoever, but I want us to treat the session as a common session. We all have something to learn, and I'll show some pictures and hopefully stimulate everybody's mind to think about it. I cannot, begin any other way than acknowledge Professor Roten's contribution to neurosurgical anatomy and neurosurgery altogether. And I also want to highlight this website where lots of his pictures can be viewed in both in 2D and 3D and to learn anatomy. Also, these are two books that I highly recommend. I have specifically chosen insular surgery. I appreciate it's very complicated, but also it's very good for reviewing anatomy, and that's pretty much why I've chosen it. As the two previous speakers have done, demonstrated and introduced lots of the anatomy that I will be talking about. So really my talk is going to be a review. And as a previous speaker said, anatomy is really a repetition. Actually, the reason I showed this picture here is because lots of the background, how I think about low-grade glioma surgery and glioma surgery in general. I won't be talking about it here, but it can be read pretty much in this chapter that has been published in this book, edited by or co-edited by Rames, who is also in the audience. Essentially, it's about on-court functional balance to take as much tumor as possible without causing impairment in the quality of life. And also, this picture is to show the time dimension. There are certain things, particularly in context of low-grade glioma, that we may need to invest in future so as the balance, not only now, but a year later, 2 years later, 5 years later, 10 years later, is going to be just right for this individual patient. And also, you've seen me saying this many times, and as everywhere else, it is all about getting in, getting the money and getting out without being caught. And we need to select a route, and broadly speaking, there is transopercular route and transsylvian route, which actually are very similar. One can even use combination of these two. I personally, and the talk is very much how I do it, I would choose the transopercular route for gliomas, especially low-grade gliomas, and transsylvian route for non-glioma lesions, and also for glioma, including low-grade glioma, and specifically when the lesion is confined to insula, particularly one in zone 1 as defined by Berger-Sanai classification, i.e. in the anterior, inferior insula, and identification of where simply there is very little doubt or no doubt that there is a language infrastructure in this area, and particularly in a patient who cannot be done during awake surgery. So awake surgery would be preferred way of doing it, both on the dominant and non-dominant side. And we have to be aware of the dangers en route. And the dangers are related to brain and vascular supply. Brain, again, cortex, as we discussed earlier, perhaps slightly less so important, mostly because of plasticity. but we need to be aware of pars opercularis, particularly on the left side, and most of the time we can take most of it, but not always. And the primary motor cortex and white matter tracts. Now be spending some time about it. We've already heard of the acute fasciculars or the superior longitudinal fasciculars, which is the other name for it, IFOF, antennate fasciculars, optic radiations, and of course corticospinal tract. And I'll spend quite a bit of time, I think, on talking about the vasculature, because that's where the permanent deficit comes from, including in my patient. All the white matter tracts really are concept and simplifications. Really, we are now moving towards a more sophisticated view of the white matter connectomics, and there are some of our papers that come from our group if you're interested in reading. I'd like to acknowledge Professor Baldoncini, who I know is in the audience as well, who gave me these two beautiful pictures. And I've chosen these particularly to illustrate the location of the insula, which is hidden behind the opercula. Operculum means curtain, which are frontal opercula, central operculum, parietal operculum, and temporal operculum. I prefer the division of the lobes into frontal, central, and parietal, temporal, and insular, as well as the limbic that we can't see. It's also good to learn this sort of cross-sectional axial anatomy that we can see on scans. And I would recommend to any young budding neurosurgeon to try to learn these as soon as possible, because it'll just repeat itself and you will understand a lot of what's going on. So in terms of lateral to medial, you can see the cortex of the insula, you can see the extreme capsule and claustrum, the external capsule, putamen, globus pallidus, and thalamus with the anterior and posterior limb of the internal capsule genu here, and that's foramina Monroe here, just a bit of the fornix there. And you know, once you have it in your mind, you can actually see all of that on any half decent scans. It's a simple T2 axial, you know, fast to acquire image. You can see the head of the chordate, you can see anterior limb of the internal capsule, you can see the putamen and posterior limb, and so on. You can see the optic radiation starting from more or less the lateral geniculate body. And I'll do one sort of step by step dissection that will be that is worth keep repeating, because it will help us understand the anatomy also when we look at the scan. So I won't be repeating the opercula. You can already see the insular apex popping up underneath the pars opercularis and triangularis. Here the central lobe is retained, and you can see the mostly U fibers at this stage, and some of the opercula have been removed, and you can see, as before, beautifully seen in the previous speaker's talk. Classically, you talk about short gyri and long gyri, and that the anterior part of the insula is short gyri with 3, and the posterior is long gyri with 2. There's quite a bit of variation, and also depends which angle you kind of look at it. We talked about the limen insula. Limen is a word which can mean doorstep or door or opening. And the reason we call it limen insula is because there's a door in the insula. You can actually see it, you know, you can imagine it's a door through which the MCA enters or exits the sphenoidal part of the Sylvian fissure, entering the insular part of the Sylvian fissure. We'll see it a bit later on. So we've removed the cortex of the insula. Now we see the insular white matter, which is the extreme capsule. There's a bit of a suggestion of already claustrum starting there. And after the claustrum is removed, there's a external capsule, and then you can start seeing the putamen, which is the gray matter. You can start seeing the uncinate fasciculars, which connects the frontal and temporal lobes. Now, it's always important when you look at it, what is the function? One of the functions of the uncinate fasciculars is, as we heard, is supplementary to speech. Generally, there is a little effect purely by removing uncinate to the speech. Some of it is very likely related to the IFOF. Uncinate fasciculars probably is related, particularly on the non-dominant side, to mentalization. Mentalization is the kind of the ability, for example, to read people's mind. For example, you can use a test of reading patients' emotions through the appearance of their eyes. And that's one of the tests we're using. So again, uncinate fasciculars, IFOF, which we have heard about, putamen here, and you can start seeing the internal capsule. There have been slits cut in the internal capsule to demonstrate the deeper part of it, particularly in this location, part of the striatum, which is the caudate nucleus. And we go in deeper and more inferiorly. Soon the putamen will turn into, when we go through the into globus pallidus. Actually, going backwards, I just want to show and highlight the IFOF joining the sagittal stratum into the occipital lobe area. And there is the internal capsule, and with the internal capsule in the retrolenticular part of the internal capsule, you will start getting optic radiation fibers as well. Now, it's sometimes difficult to imagine it, but this picture will hopefully help us. So we see optic tract, lateral genicular body, and from there, the optic radiation fanning out in the roof of the lateral ventricle, particularly around the atrium, but also swinging anteriorly. So if we just look at the retrolenticular part of the internal capsule, you can see it here. And then again, trying to look from here, if we flip the brain the other way, you can start seeing the optic radiation fanning out across the atrium of the lateral ventricle this way. And that's the, previously mentioned Mayer's loop. Here is the anterior commissure, and here is another bit of gray matter, which is the ventral striatum, more medially ventral pallidum. This is sort of cross-section helping us to understand that. So again, dorsal striatum, ventral striatum, dorsal pallidum, or the main pallidum, ventral pallidum, and more medially to that, which would be kind of in depth there, anterior to the anterior commissure, which is here. We can see nuclear accumbens. You may be surprised to see a bit of amygdala, which extends, as the previous speaker has been saying, from the anterior segment of the mesial temporal lobe all the way through through a very medial aspect of the brain here. It's another picture of the same thing, anterior commissure, all the fanning of the internal capsule. It's a retrolenticular part of it, and that's the substantia innominata, which contains the ventral striatum, ventral pallidum, but we don't really have time to talk about it. All I'm going to say about it, you can see the anterior perforated substance here. All I'm going to say here, we really don't want to be damaging this area. To be honest, we will not be even allowed to go there, because there will be all the lateral ventricular striate arteries coming through. Now, I will quickly run down simple sagittal MRI scans. You can see, as in the dissection, a short gyre of the insula, long gyre of the insula coming, Lehman insula here. We can't quite see it, but here is the MCA coming through. You can start seeing putamen. You can start seeing the the internal capsule. That's why it's called corpus striatum. Putamen together with chordate nucleus are called corpus striatum because of the stria of the internal capsule. They grow through it and then divided into laterally placed putamen and medially placed chordate nucleus, which starts becoming very obvious here. There's the ventral striatum here that we talked about, and you can actually see the anterior commissure right here. So if I was to go backwards, you can actually trace the lateral commissure, the anterior commissure right here as the brightest bit of the white matter. So you know, take your time and have a look at your scans, and you'll see much more in it than you perhaps have imagined. Let's talk about the vessels. So the vessels are really MCA that we are interested in, together with its main branches, and perhaps I should say that after bifurcation it's called M2, before that it's called M1, and the when it is in the opercular part and underneath the operculum is called M3. When it emerges on the surface is called M4, and then if it then dives into a sulcus on the cortical surface is called M5. And lenticular striate arteries are here. I'll address them a bit later on. So it's a cross-sectional picture showing M1, a bifurcation of M2, usually through the to the dorsal and caudal trunk, and the number of lenticular striate arteries can vary from pretty much 1 to 18 or 20 in some papers, and it's important to appreciate the vascular supply division, which we'll touch on later on. We'll probably skip the picture, but it shows as the MCA comes out around the limb and insula and divides into the cranial and caudal trunk. This is to demonstrate the M2s running over the insula. Then when they go to the limiting sulcus of the insula and flip underneath the operculum, they become M3s. And these are small branches that supply the insula. This is the short 3 gyri and 2 long gyri, posteriorly heschel gyros of the temporal lobe. And most of them, pretty much all of them, with some exceptions, they supply insula only. I'll skip this picture just to show some of the lenticular striate arteries going and fanning into basal ganglia and the internal capsule. Of course, you can imagine what happens if we damage any of those, but I'll focus on this picture in particular. So here are lenticular striate arteries going basically through the old central core superiorly here, but I want to also highlight some of the branches of M2s and M3s. Generally, they are divided into short, medium, and long. The short ones will pretty much supply only the insular cortex. The medium ones, which are only 10% of them, claustrum and maybe external capsule, but there are also long ones, which we need to be very much aware of that, particularly in the posterior aspect of the insula, that can supply corona radiata. In terms of how the surgery is done, this would be sort of typical positioning of a patient for most of awake surgeries. But for insular surgery, and most people will position patient like that for insular surgery as well, I prefer to position patient in this sort of angle, and this is mostly to allow work on the posterior aspect of the insula, given the orientation of the sylvian fissure. Some people would do it more in this the flat position, and they will then have to extend the opercular windows more posteriorly, all the way through not only through pars triangularis and opercularis, but potentially also through the parietal operculum to get there. This is the division of insula into 4 different parts by Sanai and Berger. And you can see that to reach the posterior part of the insula, zone 2, which generally has the lowest resection rate, if you go purely transopercular and position the patient flat, you have to remove all the way back as the parietal opercular. Let's have a look at some cases. 62-year-old woman, vivid dreams, waking up with odd taste, mild impairment of verbal memory, and so on. So here's the picture. You know, very few insular tumors are purely insular. About 30% in R series, and so this was approach transopercular. What we are looking here is a right frontal lobe here. We're placing a strip electrode on the primary motor cortex for continuous monitoring of the corticospinal tract. We already did some partial temporal lobectomy, while you can see already the pia of the medial temporal cortex with subpial work. So it's a massive window here, because we could afford doing temporal lobectomy. Not only afford, but we had to do temporal lobectomy here. So here is a pars triangularis, and that demonstrates that's the insular surface pia. So we went through the lateral pia, medial pia of the frontal operculum, and now we'll be cutting the pia of the insula, going to the insula. I'm deliberately showing it here because I have found that it's very confusing to lots of people who haven't been exposed to insular surgery, particularly the transopercular route. So in essence, yes, it's subpial, that once you get in, you then stay subpial in relationship to the insular pia, but actually you transgress 3 pias, which is the superficial surface pia of the frontal lobe, then the deep opercular inner pia, and then the pia of the insula. Yeah. I think that's pretty much all I wanted to show on this picture. So once you are then subpial, you kind of stay subpial, and most of the branches of the MCA will stay within the Sylvan-Fisher pia. So in this sense, from then on, it continues to be subpial work, and the MCA and the branches are protected from the potential trauma of the surgery. You can see monopolar stimulation looking and checking for the corticospinal tract. Anyway, so this has been done, decent resection, apart from the posterior area right in the insula. And the reason was that we had decrease of the amplitude of the MEPs, and which led to temporary weakness. Thankfully, we stopped early enough that this weakness didn't translate into permanent weakness. This has been in itself stable over last several years, but the tumor itself spread along the corticospinal tract all the way to the temporal area, into the midbrain. Now, the second case, 19-year-old female ambidextrous, had a seizure. So again, you can see this is not confined just to insula, which would be kind of the zone 2 insula, posterior superior insula, but also frontal lobe. Again, no other troubles. We identify this perfusion MRI. I've identified this area to be of the highest perfusion. So this was the main target of the operation, potentially signifying the highest metabolic activity, which maybe correlates with the most aggressive part of the tumor. So this is a post-operative scan. You can see the extensive hyper intensity on T2, and you can also see diffusion all this area, well, which is outside the corticospinal tract and of the posterior limb of the insula, but within the corona radiata. And again, we had to abort this. So that's the pre-op. This is the post-op. We had to abort the surgery, and this is the delayed scan showing not only effects of surgery, but also the ischemia. And that's the intraoperative finding of when everything was fine, and then when MEPs went down, and that's when we stopped resection in this area. And this is the patient later on. So she did recover, but she woke up completely hemiplegic and stayed nearly hemiplegic for over a week, and she had to undergo quite a lot of rehabilitation. So this is actually my patient who with a permanent neurological deficit, even if she finished her university, and is generally doing well. That's another case, 34, male, right-handed, just presented with seizure, occasional dyslexia. He was done awake, as all the other patients, and again, you can see the area of enhancement here. It actually turned out to be a GBM eventually, so we focused on the area in depth. So right frontal lobe, right temporal lobe. You can see the tumor in the anterior sylvian point, more or less. So again, opened the opercular. We checked for any speech infrastructure, which thankfully there wasn't. And if the patient doesn't tolerate the surgery very well, we can then put the patient asleep once we confirm that there is no speech infrastructure. I forgot to say that when we go transopercular route, we always pretty much identify through the frontal operculum anterior and aspect of SLF, which usually manifests itself with phonological errors. And when we go through the temporal operculum, we try to identify and do identify at the beginning of the surgery IFOF with various semantic errors. And once we identify that, we know the boundaries of our resection. That's really kind of the essence of it. And again, what you can see through the, so we're checking for, this was bipolar stimulator with which we check for speech, and monopolar stimulator, which we check for motor function. And basically you just keep going till you enter your functional boundary. And again, that's a post-op scan. Apologies, that's slightly thin because it was prepared for 3D. Now, we also have to be honest with us as neurosurgeons. We have a tendency to see ourselves somewhat differently than maybe the reality is, and we need to ask ourselves, are all patients perfect, or some of them a little bit like that? And that's why review of our results is absolutely necessary to make sure we're doing what is worthwhile doing for the patient. And if not, then correct it. Thank you very much for your attention.
Roy, you are there, Roy? Roy Daniel? Okay, so...
sorry, Atul. Roy has excused himself. He has to go to urgent surgery doing decompressive apoplexy.
Okay, so Tom, that was a fantastic presentation. I know you were touching on a very difficult and a very complex subject. And you know that neurosurgery is a big leveler. You have a very big success one day and you may have a very disaster next day. So this is the life of a neurosurgeon. You presented it beautifully with some fantastic slides. What do you say, Imad? Was that fantastic?
Was very good, but I'm seeing Dr. Ibrahim Sbeh has a question, and we will give him the privilege.
So before Ibrahim, before you ask a question, I will ask Victor to make some comments so that then we can, Victor.
Excellent presentation, very nice pictures. So the videos really clear. I think most of the participants are learning another skills from this experimented brain surgeon and friend. Thank you.
Thank you very much.
So much, but that was fantastic. And we have one comment for you from Ibrahim. Ibrahim, please go ahead.
Thank you very much indeed. I just want to ask Thomas, what's your views about, of course, this is a question for you and for all the panelists. What is the value in your mind of using 5-ALA and use intraoperative CT or MRI in achieving better results in such kind of glioma surgery?
Yeah, that's a difficult one. It's a big debate. Intraoperative CT in the context of insular surgery, I'm not sure exactly what would be the benefit. I suppose updating navigation if this is what someone is heavily relying on. I would say the main place to stop should be either so functional anatomical or vascular boundary. So any sort of imaging, I think, is not sensitive enough in this area. But I admit, although we don't have it, that I can imagine intraoperative MRI can give one feedback, you know, where are we if one is not exactly sure where we are, and you know, which is not a bad thing.
Now, Thomas, one question is there. I want to ask you from the panel. I want to ask you, what are the intraoperative maneuvers like awake craniotomy, monitoring? What are the intraoperative maneuverings that you do to prevent damage during insular surgery? Can you just summarize?
Quite a few, but let's say awake. First of all, I like to be sure that there is no speech infrastructure. Once I'm sure that there is no speech infrastructure, then if necessary, we can put the patient asleep. If we go, often because insular surgery actually takes, in my hands, quite a bit of time. Once the patient's asleep, you will need something, and your minimum you will need is monitoring of the corticospinal tract, for which it is good to have a monitoring through MEPs, but then mapping via, I usually use a monopolar probe. If the speech infrastructure is there, then of course you need to identify all the components, and if you want to go further, then you need to have online feedback that the patient is okay. The MEPs, the reason the continuous monitoring of MEPs is useful is even though you know exactly where the corticospinal tract is, you can occasionally have, as we've discussed during the anatomy, for example, long branches coming off M2 or even M3, well, M3, but mostly M2, which can supply deep structure, not only the insula itself and the insular tumor, but also, let's say, corona radiata. So if let's say I'm having MEPs going down, I will pause, and often they recover. If they don't recover, I'm prepared to stop the surgery, because last thing I like to do is give a patient permanent deficit. So far I have one case, the ones I've showed you. I prefer to err on the side of having a healthy patient, but and preserving maximum quality of life of the patient. Of course, we could then enter into this philosophical debate about the role of surgery and so on, but that's beyond the scope of this talk, I think.
That's right. That's right, Thomas. That was fantastic. I can
I have
imagine.
one question.
Yes, Imad. Imad?
Well, very nice presentation, Tom. And I have a couple of questions. Of course, monitoring, you mentioned about the motor evoked potential, which is essential to avoid the posterior limb of the antenna capsule body manipulation. The problem with there was a question from Ibrahim about the intraoperative MRI, which we have. Unfortunately, intraoperative, it can guide you for the extent of the resection, but not guarantee the functionality preservation. And you can have over-reading or under-reading of this MRI. And early changes might not reflect positively on the MRI, so you don't know whether there is some ischemic changes by the manipulation of the vessel. The other things, I want to ask Tom if he used papaverine or any antispasm material during the resection, because sometimes these perforators from the insular area, from the middle cerebral artery, they might go into spasm. We were discussing the other day with Pablo as well. We use the papaverine. What does he use to avoid or delayed or avoid spasm?
Yes, I also use papaverine. Sometimes simply raising the blood pressure can help, which can improve the MEPs, and simply sometimes just waiting. One thing which I didn't mention, because there are a lot of things to mention, is one has to be quite careful using ultrasonic aspirator, particularly around the tiny little vessels. They can send arteries to spasm, and also potentially cause damage directly to the brain further away, saying that using low setting can also help.
Thank you.
May I make a comment?
Yes, yes, please. Yes.
Dr. Abdul. Okay, go ahead. Dr. Atul, there are several questions, so I think we don't have enough time. I think professors could answer that questions. There are at least 6 or 7 questions in the panel, answers and questions. Maybe Dr. Thomas Santerius, you can respond that in the panel. Thank you so much, Dr. Thomas.
Victor,
very nice
presentation. One question from Professor Tomasolo. Yeah.
Professor Broggi as well.
Broggi. Professor Broggi, please go ahead.
Yeah. I would like to make a comment. I have very short experience with the intraoperative MRI, but I completely agree. Images are not giving you function. So the most important things is awake surgery and monitoring and continuous stimulation of side-by-side stimulation. About the vasospasm, I think that all the surgery should be done a little bit above the pressure of starting when you start the surgery. That is the major advice that I can give to the young people. Thank you.
Can I just last comment? I agree. Thank you very much for this contribution. I have to say I had a number of loss of amplitude during the surgery, but as long as the amplitude is reasonable, I haven't had permanent neurological deficit apart from this case I showed. So it's actually quite valuable, the ongoing monitoring.
Okay, Thomas, that brings an end to this, apex of neurosurgery. Insular surgery is the ultimate. You see, you have to have absolute microsurgical skills, absolute information of neurophysiological information about the brain, top class anesthesia, patient helping you during the surgery. And all these things combined, rational and philosophical and absolute technical way of operating, you can have good, beautiful success. There is no question about it, but failures can be quite devastating. Thank you very much, Thomas, for this beautiful presentation. And I ask Victor to introduce our next presenter. Victor, please go ahead. Victor. So if Victor is a little bit, Victor. Okay, Victor. So I introduced our next guest, and that nobody.
Victor is with you. Victor is going to present, I think, Professor Benish, is it next?
Yeah.
Yes, okay. Okay, now we have a very nice and marvelous brain surgeon, head of the Neurosurgical Anatomy Committee, and we have the lecture surgery of pilocytic astrocytomas. Thank you, Dr. Vladimir Benes, to this webinar.
Okay, good afternoon, or morning, or late afternoon, or evening, or whatever to everyone. I'm going to talk about the pilocytic astrocytoma, which are spread all over the brain, and it means that I cannot dwell on literature, I cannot dwell on anatomy, because they are in all the regions. I have asked our residents to compare what we had over the past 19 years, and it was 47 patients, and I now will go through them with you and probably raising some questions. These tumors can be divided into 5 groups. It's spinal cord, which is standing apart a bit, and then the good ones, cerebral and telencephalic pilocytic astrocytomas, and then the bad ones or difficult ones, it's diencephalic and the brainstem. So let's go through all these groups. We all know, and it's published many times, that the extent of resection predicts the risk of progression. The last publication is from 2019. And we are dealing with pretty benign lesion. The 5-year survival is above 80%. So it means that we should be really careful, and we should be thinking about the indications for surgeries, especially in the deep ones, because it's not that difficult in the superficial ones. Spinal cord, 6 cases for cervical to thoracic, gross total resection in not a single case, but in 4 out of 6, it was subtotal resection. So let me show you the cases. One was 54-year-old woman. She's after surgery neurologically intact. You see the tumor before surgery, and you see the remnant 3 months after surgery and 8 years after surgery. And this depicts well that the dynamics of the disease must be counted in years or even decades, not in weeks or months. So we are dealing with a lifelong disease in a way. Another one is 50-year-old woman. She has some proprioceptive dysfunction after resection of this tumor, which is before. This is 4 months after surgery. It's a little remnant 5 years after surgery. One would tend to say that this is the scaring, that this is not really the tumor, but one can never be sure. The interpretation of these two images is somewhat difficult. Telencephalic, those are the good ones. 9 in total, gross total in 7 out of 9, subtotal in another one, and only in one we have to back out because there was, you will see the case. No regrowth, all the patients are doing well. 41-year-old woman, neurologically intact after surgery. You see the tumor in cuneus region. She has had seizures. Now she is on medication, but with very, very rare seizures. And this is quite long follow-up. 7 years after surgery, doing well and no relapse. 58-year-old man is after surgery neurologically intact, but this was a difficult case because it went into the fornices, so we backed out. We just released the cyst and resected part of the tumor. This is what it looks like 4 months after surgery and years after surgery. This is 3 years follow-up, and the tumor is changing in shape. The cysts are changing in shape, and one shouldn't be really nervous about that because these tumors are really changing in appearance over the time. And what's important is not really the MR image, but the neurological status. Once the patient starts deteriorating, we should think about the surgery or reduce surgery, not any earlier. 27-year-old man is doing well after surgery. This was his tumor. This is the only case with neurofibromatosis. All the other cases were sporadic disease. This is his tumor. And you see 5 years after surgery, there is no relapse, no nothing, and the patient is doing rather well, even with his neurofibromatosis. Cerebral pilocytics, they belong into the good ones, 15 in total, quite frequent, especially in children. But since we do not have children in our department, I'm not going to talk about them. I must be doing them elsewhere. 9 hemispheric or peduncle, 6 in vermis, and gross total resection in 14 out of 15, and no progression whatsoever. 28 years old man, neurologically intact after surgery. This is probably the best case of pilocytic astrocytoma. This is 9 years after surgery, no relapse, no nothing. 25 years old man, again, neurologically intact after. This is Vermean, think in the ceiling of the fourth ventricle. This is 6 years after surgery, and the patient is doing perfectly well. This is the most recent case. This is the tonsillar pilocytic astrocytoma, which is a really nice surgery and somewhat easy because you just remove the tonsil. And the only thing which one might question, and as a resident, I've been told that we should resect the cyst wall. So we are still doing it whenever possible, that we use the wall of the cyst. But to be quite honest, I'm not sure whether that really is necessary. And you will soon see a case where we didn't do that and nothing really happened. And I don't think that this is too different from hemangioblastomas, where you, of course, leave the cyst. You see the pica, which is pretty adherent to the tumor, but still the tumor may be kept in one piece and going slowly around the tumor, around the tonsil, whole tonsil. You release the tumor from the brainstem, from the vertebral artery, 12 nerves, higher up, 9th and 11th. These are already the cervical roots, and this is really beautiful surgery. This is the 12th. Obviously, there's the pica, which is running upwards over here. And let's just probably move forward. This is the upper part of the tumor where the tonsil is being transected. And up here is the cyst, which we, at the end of surgery, resected by CUSA. This is the final point, and let's see the beautiful anatomy of the CC junction after the tumor resection. And that's it. All intact, all in continuity, all the monitoring normal, without any change throughout the whole surgery. This is the MR after the surgery, some 2 days. This is the 2 weeks old case, which is not, diencephalic. We are coming to the difficult part. There were 6 of them, 3 thalamic and 2 optic or thalamic optic tract. Only in one case were we able to resect the tumor entirely. Otherwise, it was subtotal resection and one only very partial. On the other hand, we didn't see any progression. This was the easiest case we have had, the pilocytic of the optic tract. I never ever saw the middle cerebral artery, yet it got occluded, young girl of 18, and there was ensuing major infarction, very unhappy case, and very dramatic post-op course. This is the final image 1 year after the surgery. Fortunately, since the patient was young, we got rather by with that. You see, when she was hemiplegic and aphasic, now 1 year after the surgery, she only has mild speech disturbances. and she studies architecture, which means that she's pretty normal in all her mental capacities. Another case, deep in the posterior thalamus with a large cyst, which really helped in this. This is the approach supracerebral infratentorial, lateral coming to the lateral mesencephalon into the ambient cistern, but even with this maneuver, we still were a little lower than the cyst, and we didn't want to enter the mesencephalon or thalamus at this region. It was really mesencephalothalamic region, and thus we dissected the tentorium, little V-shaped incision. This is still underneath the tentorium, and we are still below the cyst. This is the lateral aspect of the mesencephalon, which is being freed. You see the circumferential perforator over here, and we needed to get a little higher up, which is somewhat easy. The only thing cutting the tentorium is to have some hemoclips prepared, because Pablo already has mentioned that there are these stupid venous lakes which you must be prepared to traverse either with clip or with coagulation, but sometimes the coagulation of the dural folds is not really that easy. And after the really little opening of the tentorium, we got enough space to get the necessary 10 millimeters higher up to see the Rosenthal vein and to get above that circumferential perforator. You see that the dura may be very thick, and at the ring of the hiatus there usually is at least one venous channel which must be handled properly. This is already the base of the temporo-occipital region, where Pablo has perfectly shown how to resect the glioma through this, and I would add a meningioma being resected from here. And now we are underneath. This is the Rosenthal vein. This is the tiny perforator which we have seen from below, and going a little bit above, we are getting to the thinnest part of the mesencephalic tissue, and from there on we can enter into the cyst, into the cavity, and you actually are directly in between the pyramid tract, which is anterior to you, and between the oculomotor nuclei, which are dorsal. So this is the safe zone to enter. Here is the cyst being entered, and directly opposite the tumor is located, and it was rather easy and nice pilocytic astrocytoma over here. Let me show you the end of surgery, which is over here. Already the tumor is being resected, still nice and open the cyst, and this was exactly the case where we obviously didn't resect the cyst wall, because that would be very, very stupid move with any chance of any benefit to the patient, but the danger. All right, and this is the patient 1 year after surgery. He's got no problems, no deficit. He only had post-op epidural hematoma, which is always with these difficult cases, you must have at least some complications. Another in the anterior thalamus, there was a 24-year-old girl who came to us with spasticity on her right hand. This even was operated by some plastic surgeons. The tendons were cut, and she still had the problems. You see the tumor, which is medial to the motor tract, which is not really the best image you see here. It really worries me always when I'm that close to the region. We went transcortical directly to the lateral ventricle, and then transchoroidal posterior to the foramen Monroe. And I'm always leaving the choroid plexus medially, somehow to get a little protection of the medial structures. Here is the thalamostriate vein, here is the choroid plexus and foramen Monroe, and this is the tumor. And here we are This is intra-op, which is extremely helpful, the intra-op MR in all these cases. And we always schedule the surgery for DOR with the intra-op MR whenever possible. And this is later on, I guess 1 year after the surgery. And this is the patient who is doing perfectly well and having no problems. Male, 15 years. And this was the most complicated case. At a regular check by a local pediatrician, there was a decreased vision. He was sent to our department, and he was sent there for the next 2 years. So this is when we came in, when we did the biopsy. It was pilocytic. This is May 06. You see the tumor. We've resected part of the tumor. April 08. The tumor still works. You see the new cyst, and you see the compact part of the tumor. April 08, second surgery. Again, looks rather nice on intra-op MR, but this is what it looks like later on. Like nothing has been done except the cyst evacuation, but that's not true. February 08, 09, you see the new cyst formation, another cyst in the depth, another surgery. This was already fourth major surgery for this tumor. This is up to 2 months after the last surgery with lots of drains, lots of shunts and omayas, whatever you name it. The diversion of CSF was really a nightmare. And this is February 10, and since then, this is stable. This tiny secondary nodule was irradiated by gamma knife, and it's stable. And even the patient is stable. This is October 17, and this is the boy, which is neurologically intact. He's very good at skiing. And over the 2 years with us, he has had 36 MRs, 34 CTs, nearly 2 years on and off in a hospital. He was twice very close to the do not resuscitate order. The condition was really, really grave. 4 major surgeries, repeated shunts, extraventricular drainage, omaya, whatever. But the fight, as you see the patient after, was worse. He's on no medication at all. Another of these tumors for decreased vision, partial resection only. And these are funny tumors. You see there are 2 articles in the literature. This was in child's nervous system by my father, 28 patients, and he recommended surgery. Then in ACTA was another 26 patients, and surgery was not recommended. Funnily, this guy was my father's deputy, and these patients are exactly the same cohort. So 2 guys evaluating the same patients, one coming to a conclusion that surgery is recommended, the other one that surgery is not recommended. And I'm pretty sure that it's still unsolved issue, these unpleasant gliomas. Brainstem pilocytic, we have at 8 in total, 3 in medulla and 5 in mesencephalon. Gross total resection in 1 of 8 in mesencephalon. Subtotal again in mesencephalon. In oblongata, we have failed to do anything better than partial resection, and this was exactly the case where we have seen the progression of the disease. This was a 43-year-old man with atactic gait, and there was the medulla oblongata tumor. We finally reversed to fractionated radiotherapy. Here the tumor looks rather nice, but whenever we touched it a little more aggressively, the evoked potential deteriorated, so we really did nothing much. And this is progression after 15 months when we recommended him for brachytherapy. He's still doing rather well, but he definitely is neurologically not intact. 42 years old woman, sudden onset of diplopia. She came in neurologically intact. After the surgery, she has that left-sided hemiplegia. I will show that to you why. Now she's doing perfectly well. She only has mild acroparesis of the left leg. This is a tumor in the quadrigeminal plate. At first we thought this could be a cavernoma. It turned out to be pilocytic astrocytoma. The surgery was very straightforward and rather easy. What happened was this embolization and the ensuing ischemia in the right hemisphere, but now she's doing rather well. Another patient, 33 years old female, top of the mesencephalon, the tumor. There was a short loss of consciousness while she came to us, and the surgery was performed again via transcortical, transchoroidal route. And you see the tumor, which was rather directly accessible, but yet we have left a piece behind, which you will see here, because there it was not the monitoring, it was my fear to damage the girl, and knowing that it was a pilocytic, I was aware that we can leave piece behind and be quite happy with follow-ups. And this is the girl some 2 years after the surgery. So what to tell to in let's say as a conclusion for this pilocytic astrocytoma, it's the age. It's dominantly pediatric tumor, one of the good ones for the pediatrics neurosurgeons. There are 3 groups, which is spinal cords and the part, and then the good ones with telencephalon and cerebral ones. It's exactly how Pablo in the first lecture has divided the brain from phylogenetic point of view. And those in the old regions, in the encephalon and brainstem, are the difficult ones. Of course, the result depends on the resection radicality, the overall survival, but it's not the only parameter. Approaches are individual since the tumors are growing everywhere. Resection of the cyst wall is recommended, but I'm not sure whether it really is needed. All the maneuvers which ensure your safety for your patient should be used. This is the monitoring, intra-op MR, tractography, whatever you name it, good anesthesia, everything. The perspectives of pilocytic astrocytoma is in genetics, as in whole neurosurgery. This is this BRAF V600E mutation, which is a positive factor for overall survival. But as in all these genetic things, is as yet unproven. So targeting BRAF in pediatric low grades is unproven, but for several years it's under investigation. Another avenue is the intracavity radioactive seeds. This was done by Thorn in Munich, and this is one of the publications. And again, it may be done and should be done in one step. We have sent one of our patients very early on to Munich, and we didn't see any difference. The patient was doing well, being radioactive, but without any progression of the tumor, as well as the others which never ever had any radioactive seeds. So it's still again under investigation. So pilocytic astrocytoma in general is a surgical disease by all means. That's the only glioma which can be treated by surgery. The patients are usually asymptomatic or with minor complaints and deficits only. And this is important because I don't think that asymptomatic patients should be treated surgically. First, one must really prove the growth of the tumor, and some neurological symptoms should appear. Unless this happens, then probably the observation is the best treatment modality. Especially in the diencephalic and brainstem tumors, we expose the patients to high-risk surgery with certainly proven benefit, but the higher the radicality, the higher the risk. So what's important is the balance and is all the maneuvers, how to ensure low-risk surgery. And of course, as has been said many times, remnant is better than the deficit. And the observation is a legitimate policy. So what's pilocytic astrocytoma? It's dynamic lesion. Cysts and even the tumor itself do change over time on the repeated MRs. And this shouldn't be the indication for surgery. The indication to surgery should really be real growth of the compact part of the tumor and some neurological symptoms, which are probably much more important than the MR image. And this is our committee, which I'm proud to be a part of, and I hope that we shall be doing a good work for many, many years to come. Thank you.
Thank you, Dr. Vladimir. Apart from being an excellent brain surgeon and giving excellent talks on different topics in neurosurgery, as well as writing articles and books. You are also a great traveler and visitor from many countries, leaving your mark on all the places you have visited. There are some questions I want to ask you. This is the participation of Ahmad Al-Windi. He said that, can pilocytic astrocytoma become high grade with time? And what is the response to radiosurgery?
Well, I have never ever seen an article that the pilocytic would transform into the higher grade. It's stable tumor which doesn't change over time. So the danger is, I cannot say non-existent, but I do not know about this danger. And the response to radiosurgery, that was the only case I have shown where we have used radiosurgery, and the tumor is responded rather well. But again, these tumors may even decrease in size over time without any treatment. This really is a tumor which is changing its appearance over time. So I don't know whether it really was helpful. And by definition of radiosurgery and let's say radiation in general, the response can hardly be expected because the tumor doesn't have any necrosis, any atypia, any mitosis, nothing like that. Its appearance is more or less very similar to the normal brain tissue.
Thank you, Dr. Vladimir. Atul Gol.
Yeah. Vlad, that was a great presentation. You have touched on a very, very important subject. Pilocytic astrocytomas can be present in various regions of the brain, as you have said. Most important thing is, you know, sometimes they look like enhancing cystic tumors, and they might stimulate a malignant, you know, grade 4 tumor, but you go and you get a grade 1 tumor. So that is a wonderful surprise that you can get. So what you have said is that these tumors are basically, the symptoms are, you know, much less, and they are otherwise quite asymptomatic. So that is one important thing. The tumor located in a complex area, located in the brainstem, located in the hypothalamus, but the symptoms are less prominent. So that is one thing for pilocytic astrocytomas. No matter what this is, no tumor is a benign tumor. They are grade 1 tumors. So the long-term outcome in these tumors is very, very good. The question that arises and that you have tried to answer is whether total resection is necessary or we can do with a partial resection. And you have said that if there is a possibility of neurological damage or some kind of deficit, then you better do a partial resection. Now, the other question that might come is, if there is a partial resection, whether any kind of radiation should be given or not. Vlad, can you answer that question? If there is only a biopsy taken, whether you will like to give radiation or no?
Yeah, no. We do not use radiation treatment for the remnants at all, because this really is a benign tumor with hardly any response or possible response to radiation. The only two exceptions was that secondary lesion in a young boy with occipital in trigon and in the oblongata tumor. Otherwise, I don't believe that we really can help. And as I have said, these tumors perspective, it must be considered in decades, decades. So you always have time enough to decide about another step. And should we have the pilocytic astrocytoma regrowing or the remnant growing, I probably would opt for another surgery, not for radiation.
Okay, there is one question from Thomas. Thomas, go ahead.
Just a comment. I completely agree. Also, I'd like to add that the pilocytic astrocytoma are a little bit of a mixed bag as well in terms of biological behavior. Because majority, as Vladimir said, are have a very benign course, the initial action is best to leave and only address with additional surgery or some additional treatment. Those they just behave badly. I think it's as simple as that.
So basically, my understanding will be, Vlad, am I right, that more important is to get the diagnosis? That is one. And then to have a conservative, safe resection, because even if there is a remnant, the possibility of it growing is a very small possibility. Is that right?
Exactly, Atul. Exactly. I don't think that, well, we do not operate on images. We operate on humans.
That's right.
And the patient's health is the most important one. And whenever there is a patient who is asymptomatic, and with the net of CTs and MRs in my country, we see lots of asymptomatic patients. And it's not only the case of pilocytic, it is the case of small meningiomas, small schwannomas, whatever you name it. Once you know about the tumor, it's unlikely that the tumor or the patient with the tumor will disappear, because everyone is at least somewhat responsible for his or her health and is coming for regular checkups.
That's
and
right.
You always have, in these benign lesions, time enough to act whenever this is called for. But you do not need to act immediately.
So Vlad, thank you very much. The message that another message that I got was that the possibility of radical total resection is very much in these tumors, because they are confined tumors with a well-defined plane of dissection. That's right?
Yes, right. Except for the hypothalamic tumors.
Yeah.
The optochiasmatic tumors, it's really, I would say, impossible.
Yeah.
But all the others,
I have one comment.
Any question from any other comment?
I have a comment, yeah.
Yes.
Well, I completely concurred with the approach Vladimir is doing, and we all do the same. And the most important, this issue with radiation, people take it on the easy shoulder as this is a harmless tools of giving treatment. We have to remember, even for a benign disease like a vascular malformation, this radiation therapy can be a potential for inducing tumors or transforming a benign lesion to a malignancy. So should be taken in consideration and try to avoid as possible.
Fully agree, Imad. Fully agree. I can. Do I have some time, Atul?
Yes, you please go ahead. You are the boss.
Yeah, you know, my father was a neurosurgeon. He started with neurosurgery in '49. And even now, I'm operating on patients with meningiomas, which were induced by the radiation in his patients from 60s and 70s. You know, so exactly as Imad said, radiation is by far no harmless treatment, just the opposite.
Okay, final comment from Victor, and then we go to the next speaker. Victor?
Unmute yourself.
Victor.
Yes. Sorry.
Final comment from you. Yes.
No, thank you, Dr. Vladimir. Your conferences, as always, are really nice and very useful for young brain surgeons and for all the community. Thank you so much.
Sorry, Atul, may I say something? Because Ibrahim and Takashi, Dr. Ibrahim and Dr. Takashi, they were raising their hand a long time ago.
Okay.
Thank you. I experienced once the historical diagnosis was decided. I experienced a standard spontaneous regression case. So do you have a spontaneous regression? No, decreasing pilocytic astrocytoma.
Yes, voice problems. I do not understand you.
Okay. Do you have any experience of spontaneous regression?
Spontaneous regression of
decrease. Pilocytic astrocytoma. Yes.
How many of the tumors do decrease in size actually? Negligible number of these do really decrease in size. But as the tumor is growing, you may see the decrease on MR in 1 year, and in 2 years you may see a little increase. Then in 5 years again, the tumor may be smaller. It's really like a living feature. the tumor. It's a living animal, and most likely you will see very stable volume, but changes shouldn't be surprising you.
Pablo, you have any question, Pablo?
No, I was saying that Dr. Ibrahim was also ready to ask something a few minutes ago. Sorry.
Ibrahim, you are there?
Yeah, my hand got some spasm from raising it.
You have a thalamic tumor then.
Thank you, Vlad, for a very nice presentation. You drew the comparison with the cerebellar pilocytic astrocytoma and the hemangioblastoma. Both look the same, nodule with a cyst. My question for you and for all the panels, there is controversy in literature about taking the wall of the cyst. Many papers produce some evidence that there are some cells of tumor in the wall. So what's your views about this? Should we be removing the wall of the cyst, or should we just go for the nodule?
Ibrahim, this is an excellent question which I didn't solve yet. As a resident, I've been taught to resect the cyst wall, but you have the tumors in the region where you cannot resect the cyst wall, like the thalamic I have shown. So I do not do it. We do it when it's possible, you know, like that tonsillar tumor. You can resect the cyst wall. Never do it, of course, in hemangioblastoma. But I'm not convinced that this is necessary. And I don't think that would be a mistake to leave the cyst wall behind.
Okay, so we go ahead with the next letter. Thank you, Vlad, for the wonderful presentation and very informative presentation. Now, Victor, I want you to introduce our next speaker. That is a very strong man.
Yes, of course.
From a strong country, from a mountainous country, and a beautiful country. And our speaker is Aip Cherian. Yes, Victor, go ahead.
Yes, I agree. It is an honor for me to introduce a great friend, an excellent neurosurgeon, who is doing a great job for the neurosurgical community worldwide. Aip is widely known for his contribution known as sternostomy for patients with head trauma, and now as editor and founder of Ignite Journal. Thank you, Dr. Aip, for your friendship and dedication to neurosurgery. Your talk is surgery of intrinsic brainstem gliomas. Go ahead. Thank you so much.
Good evening from here. It's always an honor and a pleasure to be back with the family. We've been together for many years through thick and thin, and many places on earth. We've been operating together and we've been teaching together. So it's a real honor as well as pleasure, both together, to be with you guys talking something about the brainstem this time. Now, I see that Tangji is also talking about brainstem. So I wanted to brief a little bit on the safe zones of brainstem. And then I wanted to show you a surgery. I mean, Vlad was talking about pilocytic. So I thought I would rather show pilocytic astro of the brainstem. You know, those are the best ones to show, because the other brainstem gliomas, if you show, well, you can take them out, but there will not be much left of the patient, actually. I mean, this is something that I realized in the last 15 years. So pilocytics, they do pretty well. So I'm going to show you some safe zones. Now, before I say safe zones, Victor, can you hear me? Can everybody hear me, please? I mean, Victor's image seems a bit frozen.
No, you have to put your slides.
Yeah. Oh, yes. I have to share content, right?
Yes.
Okay. Yes. So I hope you can see this.
Yes.
Right now. So see, when when we were residents and when we were junior consultants, we had a lot of respect for safe zones. And we really thought that these were the safe zones through which you can go and take out anything. Over the last 15 years, or the 10, 12 years that we've been doing good surgery, so we realized that safe entry zones are there, but it is safe surgical techniques that matters. So if you have retraction, bipolar, entering through these safe zones, you're going to have deficits anyway. And that's why Spetzler's 2-point theory, where the tumor comes to the surface, to the center of the tumor. If you draw a line like that, that really works. So there are few things to avoid. The biggest thing to avoid is retraction. More than retraction, you can retract, but pressure. You should have a proprioceptor. You have very sensitive proprioceptors in your fingers. So if you are retracting beyond a certain pressure, you're going to definitely produce deficits. That's one thing in the brainstem, because the whole brainstem is the size of your thumb. So if you're going to retract, and why do you have to retract? You have to retract because your view is not right. Your microscope may not be in the correct position. Your approach may not have been correct. Your planning may not have been correct. And that's why you have to retract. So if you consider this 2-point theory, where the tumor comes to the surface, to the center of the tumor, and then you plan your craniotomy as well as your approach without much need of retraction. I mean, you're going to be generally in a safe place. So these safe zones are only to understand these are areas where you can go in and produce least deficits. Don't ever.
Your screen is frozen, it seems.
No. I'm going on.
Okay.
Yeah. So there were 13 zones. I'm just going to talk about these 13 zones, but we have only 20 minutes. So we're going to show you a video also of a brainstem tumor as well. So on the midbrain, anteriorly, you have 2 zones. That is the anterior mesencephalic zone. This is just medial to the corticospinal tract. And then on the posterior surface, you have the intercollicular region. Now, there's a lot of, if you see the structure of the midbrain, you will understand why these zones are safe. This is the most important thing. As a surgeon, what you really need to do is to understand the internal structure of the brainstem and to understand how the brainstem is going to be distorted in certain lesions. And depending on the anatomical structures, you plan your approach. This is most important. So then you have the lateral mesencephalic sulcus. You have the intercollicular. Way of access. You can go to pons. Anything around the trigeminal zone is from laterally. It is safe. So you have supratrigeminal, peritrigeminal, and the lateral pontine zone all around the trigeminal nerve. They are safe. When you come to the medulla, the olive approaching through the olive is safe. And then you have the median sulcus, which is rather safe. Generally going through the 4th ventricle for lesions in the brainstem is not a great idea because you generally produce deficits. But of course, if it's coming to the surface, it's exophytic, it's coming to the surface, this is a great way to go. I mean, you really don't have to worry about the fourth ventricle surface if it's exophytic, if the tumor is coming out. But if you have some distance, a little bit of even few millimeters of distance between the lesion and the fourth ventricular flow, in my experience, probably there are other masters also here, but in my experience, you can produce pretty bad deficits. So then you have the above the facial colliculus and inferior to the facial colliculus, supracollicular zone and infracollicular zone. You can, if the lesions are little bit away from the midline, you can go on these zones as well. And then you have below the orbex, you have this posterior midline approach. So this is what we are going to use this time. I'm not going into the craniotomies that can give you access to all these. These are standard. The anterior roots are usually the pterional, transsylvian, and the lateral roots are usually subtemporal, and of course the posterior roots are generally retrosig, midline suboccipital, and far lateral. So you're going to see the images of a brainstem glioma. So you can see the sagittal cuts. The tumor is primarily in the pons and the medulla. You can see the midbrain region. And as we come to the middle cerebellar peduncle is involved, the medulla is involved, but most of it is exophytic. So, but there is good plane. At certain areas, not so much good plane according to the imaging. So we will see that. So you can see those are the two cerebellar hemispheres, and I'm opening in the region of the cisterna magna. We've done a C1 arch excision. So the sinus is being ligated and cut. So you are going from the superficial part of the tumor, and then we will go deep into the tumor. So the tumors, the dorsal exophytic part of the tumor is being exposed now. The supply from the pica is identified, going into the tumor, and that part is being taken. Pilocytic astrocytomas, they look like aggressive tumors on imaging as well as in surgery. That's the thing about pilocytic. I mean, the only good thing about these tumors are the planes are much better than many other tumors. So you will have very good planes with the brain. I mean, of course, not in the basal ganglia, as he said, as Vlad was talking about them, but in the brainstem, cerebellum, they have excellent planes, although they look very aggressive. So it's impossible. I mean, it's rather easy to go ahead, devascularize them, and keep on developing planes. In this brainstem, another important thing that you will have to figure is that when you dissect, give intratumoral traction, which means traction between tumor and tumor, not between tumor and brainstem. Never do that. So you can fix one part of the deep part of the tumor and slowly dissect the superficial part of the tumor from the deep part of the tumor. So this way you are giving traction between tumor to tumor traction. So this way you don't really put traction on the brainstem. So you should identify where the tumor is and then keep on tearing chunks of tumor from the tumor. But of course, fix the tumor which is closer to the brainstem. You should fix that part and then keep on tearing chunks of tumor after devascularization. You can keep on tearing chunks of tumor from tumor. This way, not much of traction on the brainstem. And CUSA is like manna, you know. So you can see now, you can see the tonsil, and I am going laterally. The tonsil is in this region, going laterally. You could see on the image that the tumor was on the right side. So we're going to go ahead and take that tumor with the CUSA. Direct brainstem stimulation is of great help here. This will help you to localize, especially lower cranial nerves. And as I said, now what I'm doing is I am tearing tumor from tumor, fixing the tumor below with the patties and the suction, tearing tumor from tumor. And then using CUSA. Now you can see the obex coming into the region, but we have tumor, much more tumor left. So we are taking out that part. More tumor in the depth. You will see that the entire medulla is folded in. You can see that now. You can see the medulla coming and folding in. So that was all tumor there. This is the folding of the medulla, and the pons there. The pons is there. So the medulla is coming in and folding. So we have taken out all the tumor from the pedals. That's where the tumor was attached. You can see the anterior border of the brainstem, the medulla there. That's a very thinned out medulla. I'm showing that that's the anterior portion, and those are the rootlets, the entire tumor. This is the medulla and the pons coming in there. This is the medulla and the pons. This is completely folded in. I wish I could show you in 3D, but you can see the huge crater there. And the tumor fortunately had a very good, that's the anterior part. And all that is all the lower cranial nerves arising from there. So that's the anterior arachnoid. And we have some more tumor left. So we stimulated, and we had very good responses. And this is what Vlad was talking about, the capsule. You could take it out as much as possible, but of course, I mean, if it is not coming out, definitely you are not going to do that. Now, on the velum, you had some tumor that is also being taken out now. That's tumor resection is radical. So that is the post-op scans. That is a medulla. Well, this is one of the few. Oh, sorry. I have a. All right. So So this patient comes walking, which is a great satisfaction for the suction. I mean, for the surgeon, unlike many of the brainstem tumors that you do, and you get to see them once in a while on a stretcher. So, so of course, there are tumors which can be resected, and you should go for resection. I mean, I have done a lot of mistakes with brainstem surgery. I have created a lot of deficits for patients, but I still think that if you can, for a pilocytic tumor, if you can go for a radical surgery, that would always be the best option, because you don't want to see these patients slowly deteriorating. I mean, as Vlad said, yes, we are operating on patients, we're not operating on images. So, I mean, as far as possible, a radical surgery in these brainstem tumors are always good. And as far as safe zones are concerned, there are safe zones, but these are just entry points. The most safest thing is to avoid a lot of retraction, completely avoid bipolar, and use direct stimulation whenever possible, whenever needed, and try to use as low as pressure as possible. So, and CUSA is very important. Intertumor dissection planes are very important while fixing the brainstem. Well, this way you can get as much as possible radical resections with least chances of deficits.
Thank you, Aip, for that wonderful lecture. Brainstem tumor surgery is not easy. Brainstem tumor surgery may not be always safe. So we have to be sure and safe, and caution more than valor is very important. Height of understanding of the whole thing of neurosurgery. Identification and getting the right plane of dissection, as you showed, is so crucial and important. And if you are not getting, maybe there is no harm in leaving some tumor behind. More important is to be able to define that plane and able to dissect and resect, and to identify if it is intraaxial brain tumor, brainstem tumor, then to identify where and which is the direction of entry zone into the brainstem, as you have said. And there are many wonderful zones where you can enter into the brainstem, in the midbrain, in the pons, in the medulla, and it is possible to do a good job. So Victor, comments from you, my dear friend. Unmute, unmute.
Impressive surgery, Aip Sherian. You told us that results were very well. Could you tell us about the pre-operative and post-operative state of patient? Because this kind of surgery, as Dr. Atul Gul has said, are not easy. I think they are one of the most difficult surgeries. So, thank you.
You know what, the other thing that what I like is, and I have said in the past, that in neurosurgery, nothing is easy and nothing is safe. We have to make it easy and we have to make it safe. If you say brainstem tumor surgery is easy, or insular tumor surgery is easy, or making a burrow is easy, nothing is easy. Everything has its own potential issues and own potential problems. We have to make it safe and make it look easy. So there are some questions on the panel, and I will like Aip to answer on the panel, because we are a little bit lagging behind the time thing. And Professor.
Dr.
Yes,
Subeh
yes.
has a question, has been raising his
Ibrahim,
hand.
yes. So and also Professor Giovanni, if you are there, Professor Broggi, if you want to ask a question, we'll be happy to have your expert advice.
Right.
Yes, Ibrahim.
Thank you, Aib. Thank you. Very, very nice presentation. There was some nice music and fancy pictures that appeared at the end of the presentation. I hope that you continue with that, but you didn't.
That is a booty lift for, I mean, those are my wife's and her friends' exercise videos. So.
My question, Aib, is this. There's controversy in literature about the safe entry point in the lateral wall and the lateral aspect of the pons. People speak about superior to the trigeminal entry, inferior, epi, peri, anterior. What is, in your view, and in the views also of the other panelists, the best entry point for the trigeminal? Is it superior, inferior, anterior, or where?
I wouldn't have the experience to talk about that many, because I don't have the numbers for that. So I have tried a few pontine lesions. I've taken them out completely in the peritrigeminal zone, and I've had some disasters. So I would rather not, I mean, I don't want to misguide anybody, but if there's anybody who's experienced around the peritrigeminal zone, I would like them to comment. But for medulla, we have very good protocols with medullary surgery and midbrain surgery. But pons, I've had some pretty bad disasters. I've never had very good results. So especially the pontine gliomas, unless they are really exophytic. Of course, the cavernomas, I always go by the rule of, in pontine cavernomas, if there are cavernomas, I go by the rule of what is most superficial. So, I mean, I try to not to go from the fourth ventricle, but even then I've had a lot of deficits. So, I mean, if there are anybody who's experienced, I would like them to come in rather than...
You know what, there is another talk by Dr. Tang, and let us clarify the issues with Dr. Tang when he talks. And Giovanni, you wanted to say something, yeah.
Just make a comment. I think that I completely agree. In the medulla, there is a safety zone to enter. In the pons, there is no mute zone. So you have to choose and discuss with the patient what will be the effect of the entering. I have a lot of experience at going in under the trigeminal, between trigeminal nerve and acoustic group. But you have to tell to the patient that you will have dysesthesia and you will have deafness, because passing through the nuclei, you damage that. I mean, we cannot avoid that. So that is wonderful talk that we had, and there was a very good point that.
Thank you, Professor Giovanni. Thank you. Now, one question has been put on the question box before I move on to Dr. Tang's lecture. What is your opinion on diffuse pontine glioma today? Suppose a young boy, 6-year-old boy comes with some deficit and some facial weakness and some ataxia, and you identify a diffuse pontine glioma. Quickly, because I know this is a very complex issue, but quickly, can you answer this question before I go, yeah?
I've been extremely aggressive about these tumors. I know it's not the norm, but I've never followed the norm, because these patients are going to be radiated and they're going to die sometimes. So I've been pretty aggressive about these tumors, and most of these has ended up as disasters. I mean, I have been able to take them out, but I mean, in my opinion, I always discuss with the patient's relatives. I say that either it's a biopsy, radiation, and death, or we go in and the patient dies on the table, or the patient dies sometime in the ICU. So we've gone and taken out, we've looked at all these safe zones, and we've tried to get as radical resections as possible, but the results were not very good. But there are some cases, very, very few cases, which you think is a diffuse pontine glioma, and you go and get a very good plane and you take them out, patient may not do fantastic, but in 1 year the patient does okay. I want to ask the same to the other panelists also, if they've had these very rare condition, very rare instances where you think it's a pontine glioma, it's a little bit more well defined than usual, and then you go and take it out. It ends up as with a lot of deficits in the postoperative, immediate postoperative phase, but 1 year later the patient improves. Yes, Vlad has something to say.
The pontine, the oblongata glioma I have shown, and it was not the only case I had. It's like a pseudo-exophytic tumor. As you see the tumor, you would say it's exophytic, but actually it's not. It's still covered by a thin layer of highly eloquent tissue. If you stimulate that, then you suddenly realize that you are in a wrong place, in a region where you wouldn't like to be, and you have no other option. So did it happen to you that suddenly the tumor was covered by the brain, by brainstem, despite the appearance on MR that and even optically that it's exophytic? It's not exophytic.
Yes, most of the pontine tumors are like that.
Right.
Well, thank you very much. I will like to invite Ramesh, you want to say something, or Thomas, you want to say something?
I want to say something, Imad.
Okay, Imad, yeah.
Well, for pontine glioma, we have to differentiate. We are talking about diffuse glioma. We are not talking about a focal lesion in the pontine area or an exophytic tumor. For pontine, diffuse pontine glioma, I myself, I don't touch them surgically because the outcome with and without has no values, and I will refer them for the radiation.
Professor Brogi is also.
Yes. Me too, I'm very conservative. The only thing is the DTI may put you in a mood to aggress the
yes,
diffuse. I will say no surgery.
Can I add one word? I
Yes,
believe
yes.
that diffuse pontine glioma is the only tumor which is non-surgical. As Imad, I never touch them. You can do nothing profitable for the patient.
Okay, so Thomas, last word from you. And Ramesh, if you please prepare one nice comment from your side, Ramesh. Okay, and Pablo, if you want to make a comment. Yes, Thomas.
Pretty much confirmation of what Vladimir said. I mean, I suppose sometimes there can be doubt about diagnosis, but if we are sure it is diffuse pontine glioma, then I think there's no role for surgery, certainly not resective surgery, and not even biopsy, because biopsy doesn't really differentiate the treatment nowadays. If there is a doubt about diagnosis, one can pursue some specialized imaging that perhaps can be sent somewhere else and so on. But I think surgery really shouldn't be used in diffuse pontine gliomas.
So Thomas, I agree with you. But is this the standard of care now in general, that diffuse pontine gliomas are not touched? Is this the standard of care or not yet?
Yeah, I would agree with Tom that we don't tend to do any intervention on diffuse pontine glioma if the radiological diagnosis is pretty certain. If there is a confusion about the diagnosis, then a possible stereotactic biopsy is something which we would consider. And the one comment I would like to make about the case I showed, if there is an intraoperative frozen diagnosis of a high-grade lesion, then one could decide whether to go radically as I did. But it's always an option when you have a resectable lesion whether to go radical or not. But I think a frozen section would have been a useful adjunct to it.
Yeah, that's very important point. And the point is, diffuse, as Vlad has said, Thomas has said, and I think in general this is agreed that the diagnosis, preoperative diagnosis of diffuse pontine glioma is a clinical diagnosis and also radiological diagnosis. There are very, very few instances where you can get confusion in these things. And I think ultimate outcome in these cases is not as good as in hypothalamic gliomas, can you make a comment on hypothalamic gliomas blood quickly, because we are a little bit time pressed?
I'll make it really short. No place for surgery in diffuse ones of pons. But in hypothalamic gliomas, you may decompress the optic apparatus, and that would be the reason for decompressive surgery.
Okay.
I never would aim for radical one, but for
Okay, one sentence by you, Thomas, and one sentence by Ramesh, and one sentence by Giovanni on this hypothalamic glioma. One sentence, please. Thomas.
Okay, I just had a discussion with Vladimir now. They're never, pretty much never, completely removable. Surgery should only be used for symptomatic improvement, such as decompression of optic apparatus or internal capsule or some other areas like that, and perhaps reduce the cyst size, which are often associated with the cyst, and cysts are usually the things that cause the symptoms. Sometimes,
okay,
like that, they will not grow.
More than one sentence.
I have to agree in terms of the approach to hypothalamic gliomas being fairly conservative, unless there is a mass effect causing a focal deficit. Mostly it's all down to getting a biopsy through whichever route. Some of these lesions can be biopsied endoscopically, as you know, but often they are fairly moderately managed or conservatively managed rather than doing for radical resection.
See, in general, brainstem gliomas are different and hypothalamic gliomas are different behaviorally. Whilst you can get a very good long-term outcome in hypothalamic gliomas, brainstem gliomas are usually a very, the long-term outcome is quite distressing and depressing. Giovanni, for your last word on this.
Well, me too, I'm very conservative. The only thing is you have to take out what is causing the symptom. That means the cyst or the decompression of the optic apparatus. And I think that is very important to say no radiosurgery, no radiotherapy. The patients are doing well, better than if you do these aggressive things.
Imad,
yes, I just want to say some word about the pontine glioma. What we have done recently to avoid the question of biopsy, the choline spectroscopy. Choline spectroscopy is a new technology of the past years, and it might give you a hint that this is a glioma. Once you confirm it, then you are done without the biopsy.
Okay, last word. My dear Pablo is sitting there or no? Pablo?
Here I am.
Yes, from you. Yes.
I know.
What is your, listen to the question. Yeah. What is your treatment for hypothalamic gliomas and for diffuse or for brainstem gliomas? What is the similar things and what is the different thing in these two conditions?
Generally, I really agree with all the points we have been discussing. For brainstem gliomas, I guess the point is not to damage the function which is not damaged. So with that point in your mind, you must do your best. And obviously for pontine diffuse gliomas, we don't touch them. There was a protocol in one of our cities in Spain about biopsies, but nowadays we are not doing that. And for hypothalamic gliomas, our protocol is, as Vladimir said, just decompress the optic apparatus, and then we start chemotherapy.
Okay, so I think some people like to give radiation also for hypothalamic gliomas, and there are several series where radiation has been used for both brainstem gliomas and for hypothalamic gliomas, and those series have been quite, appreciated in the world literature. So we will go on these points and several other points. I leave it to Victor to introduce our next important guest. Victor.
Thank you, Dr. Atul. Now we have a presentation of this conference named Surgery of Brainstem Gliomas by Dr. Ji Tang. Dr. Ji Tang is a successful brain surgeon from Xuanyu Hospital in China. He is the chief of a neurosurgical department, and almost 1 year ago, they performed the first intracranial resection case under a 3 Tesla high-field intraoperative MRI system, entering a nice and a new area of precision in neurosurgery. Now he has excellent experience doing surgery with this high technique MRI, intraoperative MRI. Thank you, Dr. Ji Tang.
Thank you. To have me to share my understanding about to continue the talk about the surgery of brainstem, the tumors. Thank you, Imad, Benis, the Arturo, and everyone. That happened quite common in kids. It account for almost 15%, but very rare in adult. Unfortunately, it's about 80% of these is a diffuse intrinsic pontine glioma. We have talked a lot about this. This is not suitable for the open surgery to resection, and only biopsy and followed by the radiation. And another 20%, the candidate for surgery is episodic or the focal, the lesions in brainstems. And this is a
Dr. Tang, your voice is cracking somehow. Can you?
Hello?
Your voice is not coming properly. Can you check your, the internet connection or something?
So how about now? Is okay?
Yeah, better. Yes, go ahead.
Okay, so I turn these off. So the tactile the tumors is quite benign. It's indolent the tumors, just like we talked. It's the pilocytic tumors in tactile plate the tumor. So for this kind of tumor, the patient always have the hydrocephalus. So the tumor resection.
No voice, Dr. Tang Jie. No sound.
No sound, Dr. Tang, some problem.
Sorry, can you hear me now?
Yeah, I can hear, but you fix your things.
No, how about now? Is okay?
Yes, okay, better, yeah.
Okay, so I moved to close to my microphone. Sorry for the network, not so good. So I continue my talk. So before we talk about the surgery, you should know the indolent tumors in brainstem, such as pilocytic, the tumors, and another is ganglioma in brainstem is also very benign tumor.
No sound, Dr. Ji Tang. Dr. Ji Tang.
Dr. Atul and Dr. Victor, can we move for the next speaker? But while we are trying to see what is the problem. Dr. Tangji.
Okay, so what we'll do is we will now invite Giovanni for his lecture. Just a minute. Dr. Tang, we will connect with you after Professor Giovanni's Broggi's lecture. So Victor, please introduce our esteemed speaker.
Please, Atul Gol, I think you are a very friend with Dr. Broggi. Could you?
Yes, Dr. Broggi is one of the very big leaders of neurosurgery. For several years, he's not only famous in Italy or in Europe, but all over the world. And more importantly, he is a very loved neurosurgeon. Everybody likes to hear him because with his massive experience in neurosurgery, very basic experience in neurosurgery, like our dear friend Vladimir Benes. So they belong to the same generation of neurosurgeons who have trained so many neurosurgeons all over the world. I take it my great pleasure to invite Dr. Giovanni Broggi. Please, Giovanni.
Okay, so most of the things about glioma have already been said in a very elegant and scientific way. So my topics is about high-grade gliomas, and I try to give you, mainly for the young people and the people that have, let's say, less access to high technology, some experience and advice on that. So I start with a little bit of history. Let's see if it's moving. Yes. So the surgery of high-grade glioma started with in the 30s. That means 1 century ago, with Harvey Cushing and then these follow him. The diagnostic tools were very poor. The surgical technique and the storage are very poor. Nevertheless, they did some experience, some kind of surgery. The diagnostic tools were angiography and encephalography. And sometimes during this second type of examination, the patient have problem to survive. What is happened afterward? At that time, there was neurosurgeon, neuropathologist, but now is a team. Neuro-oncologist, neuroradiologist, anesthetist. We have to work all together with this patient. There is a very nice paper about the surgery of gliomas by Patrick Kenny. And it's defined madness. Madness is doing again and again the same things without different results. And that is what, in spite of the technology advances, microscope, aisoscope, fluorescence, ultrasonic imaging, radiosurgery, the survival of our patient harboring a glioblastoma is really little changing during the last 50 years. What is the meaning there are two meanings. One is to have the clear histology, and today very important to have enough tissue to have also genetic examination. And the other one immediately is the decompress the safe brain from the hypertension. So we have navigation, we have microscope, we have ultrasound, but the main problem, as Zedi was saying, one advantage is the use of spectroscopy and the functional MRI. Spectroscopy is very important because it's a kind of biological biopsy, and that is the reason why stereotactic biopsies is going down and down. And I think there is very few indication today to perform this surgical gest. The functional MRI is quite important, but we have to remember that functional MRI is giving us the function in a moment and about a specific function, that is speech, listening, music, but the overall work of the brain, that is the thinking is not possible to be understood by a functional MRI. Nevertheless, that is quite important to decide what type of surgery to do to propose to the patient, very aggressive, just the decompression, or what else. DTIs is, we discussed about gliomas, and I think that is worth also in the supratentorial area. I mean, that is not making the surgeon safe, but is giving to the surgeon the perspective in the planning of the surgery. Most important is the neurophysiological monitoring. Also for very easy superficial frontal lobe gliomas, I guess that I personally always use neurophysiology, and I propose to the young people to have in the team a good neurophysiologist and do the stimulation. Of course, mortality and morbidity is at the beginning was terrible, but today we have a 2% mortality. That is the death in 30 days after the surgery, not immediately or during the surgery. And still we have, in spite of all the tricks that I talked before, we still have a morbidity of 80%. And that has to be said to the patient. They have to decide if accept or not. For low grades, we had a fantastic presentation before in different parts of the brain, from insular to brainstem and medulla. In the past, there was wait and see. Today, I'm saying that wait and see is only possible, and a good suggestion for diffuse pontine gliomas. For all the other is better, go ahead with surgery. And of course, there is some adjuvant therapy that are improve the situation from pump, from we will see something else. What is the goal of surgery for high-grade gliomas? The diagnosis, the relief of symptoms due to intracranial pressure increased, the control of some symptoms, the possibility to have adjuvant therapy in a rational way because we have a genetic examination. And we know that as much as we take out of the tumor, we say it's impossible to say 100%, but 9% of resection is improving a lot the quality of life and the survival of the patient. Timing, as soon as possible, I will say, when the diagnosis is such a way, and sometimes it's easy because it's superficial, sometimes it's less easy, as we heard about thalamic lesion, mesencephalic lesion. The age there is no reason to put the age is the biological age that should say. In Europe, we have some country in which if you are over 70, they refuse medical treatment. And I think that is quite very, very wrong, because the people are getting old. We have with the COVID the example that there is a lot of very old people surviving in spite of not having any treatment. So also for glioblastoma, it's better to have surgery. As I say, surgical technique, this is a very simple intraoperative MRI that we used in the past. Today there is a more intraoperative MRI. My intraoperative MRI is very expensive, and I think that ultrasound and navigation together may adjust the quantity of resection of this. One of the major things is awake surgery, bipolar stimulation. We heard all the experience that was presented, and I think that this is much more important than just to have the imaging also, and I think that definitely intraoperative MRI, it seems that it's more for surgeon than for the patient. Neurophysiology and stimulation is more for the patient than from the surgeon. fMRI, as I said, when you have to explore the region that you decide, you have to make a large craniotomy. Why, if you don't decide to do that and go to resection, you can make a very simple and small craniotomy that is much better for the patient. This is the experience of 2 years, 20 patients. You see here that the language is not has a very minor deficit, and the most important thing is that 100% have no motor function deficit. Nevertheless, we have some deficit that is after 1 month follow-up, but some of them are recovering, have a deficit immediately after the surgery, and then afterward they recover. Recurrence. I guess that if the quality of life of the patient was good till the recurrence, I will suggest to perform a second surgery that is much better of editing gas, because of course we have now monoclonal antibodies are very expensive, very difficult to find, and you cannot repeat the radiosurgery, or radiotherapy. And I think that it's much better to give other 6 months, after 1 year of good quality of life to the patient. Remember always that when there is recurrence, radionecrosis is always present, and that is quite important to have very good pathologists. We surgeon and neuro-oncology invented everything, tried everything, from inserting catheter into the lesion to deliver local therapy, use of biodegradable polymer that is very good in the first surgery. There is only one problem: they are quite expensive and not always easy to find around the world. This is the image that you can see here. That's what this typical situation at the end of surgery, and this is the control. So we had experience to, let's say, the gliadel of poor people, to put some local chemotherapy with a kind of sponge that can be surgiform or some other hemostatic agent like spongostan or so. And that is our experience on that. The recurrence you see here, you can find a blue tumor at the point. And this is the curve that is quite good. That is, in our experience, the surgical radiotherapy and biopsy radiotherapy. The difference at 1 year time is quite important. The same things is for glioblastoma. That was glioma altogether. That's from glioblastoma. You see here that again, systemic chemotherapy only when you have a recurrence is much better to do surgery for the second time. And the same is for aplastic and astrocytoma. There was proposals also mini pump, never have a very good step forward to be continue this experience. The same thing is the conventional enhanced delivery. That means to stick a catheter inside of the remnant lesion and give local therapy. And that's just, let's forget about that. And one thing, we found that the high-grade glioma of the dogs that are living in the house, not the savage dogs, but that one in the are similar as image, and most important as genetics of the one of humans. You see this in humans, and this is a pet, and the image is quite the same. And the most important thing is that the genetics is equal. what does it mean that the environment is producing glioblastoma? I'm not sure that this is the way to do it, but that dogs can be operated on and treated with chemotherapy as a human. Step forward that we already have the occasion to talk in the last webinar about fluorescence. How important it is to remove high-grade gliomas is important. If you take out that, this is the literature, if you take out more than 50%, the survival of the patient is much better and much longer. So what we can do? Neuronavigation, of course, monitoring, ecography, and I think that is a very step forward. Ecographic examination with contrast medium, because that is giving you in real time the possibility to see how much you left behind your resection. And of course, the fluorescence, both with the 5-ALA and the fluorescence on ICG, as I showed in the other time. Let's go ahead. Let's the ICG is useful if you want to see if you can remove this part of a tumor nearby the vein of Labé. The vein of Labé is already closed. You can take out the tumor without any deficit. That was the case of the patient. What about fluorescence? Again, you see the tumor. That is the 5-ALA, but you can go with fluorescing. That is less expensive, and you can ask to your ophthalmologist, and it's easier to remove mainly the remnant of the tumors. And this is some other experience and some other example here. Experienced surgeons know what is tumor and what is left, but for young people and also for old people, you have an help if you can see the situation. Look, this particular case, we know that the tumor is here. That's zerolandic, so we do the stimulation. We have to decide what we have to take away. And when we start, we see that this part in which we have the function can be spared because the tumor is on the side. And let's go ahead for question of time. And at the end, you can remove the remnant under the microscope with the head of the fluorescence. And that is making you to have a so-called total resection and with improve over quality of life of the patient. Again, another example here. This is a case that I already showed. Here is the tumor. You see here the tumor better. And that is when you remove it. You can remove with the double suction, with the ultrasound aspirator. It depends what is technology you have, but that is quite easy to remove the remnant of the tumor. And when you get to the pink, that means that it's a safe zone. And of course, you can do stimulation of the fibers to be sure that you are not making any damage to capsule of other the fibers that are descending to the motor area. Let's go ahead. That is the controlled, and you see here that the resection was quite good without any deficit. Again, I'm not going to the video because of question of time, but that is useful to find out that that tumor that it seems to have very good boundaries. That is not biologically true because we know that outside there is also infiltration of the cell, and that is the reason why we should have the radiotherapy after the removal. Also, if the MRI is showing total removal of the tumor. I already showed that fluorescence is making difference in between when it's green or not. The green area are pathological, the not green area are normal tissue. And that is again making the safe and efficient use of that. Conclusion. Surgery remains the gold standard for gliomas, low and high grade, with some limitation, as we discussed all afternoon for Italy, or for night for other people, or morning for other people. But that is remain the treatment of choice, because biology, because we know genetics examination, and we know if the patient will have a long survival or a short survival. If the long survival, genetically is a long survival, you have to undergo the second surgery, third surgery, if the quality of life in the interval in between the surgery and the appearance of recurrence is good for the patient. And the biological age is very important, not the radiographical one. Maybe I'm interested in that. The morphological and functional MRI are very helpful, but more helpful is the nerve navigation, of course, ultrasound, and the monitoring. The tumor resection is positively related with a better outcome and prognosis. And of course, we have to work with our colleague, neuropathologists, neuro-oncologists, radio-oncologists, radiation physicists, and so on. Fluorescence is making a step forward for having better results with less damage of the brain. And this paper that was quite old, more than almost 20 years ago, of Peter Black, neurosurgery is a local oncologist, because he has the coordination of all the team, but the team has to be present. Brain is every brain from John Hopkins is saying that you have to make a tailoring for each patient. It depends on the site, it depends on the lesion. You can do a partial resection or total resection, and go again if the pathologists are giving a good survival time for the patient. And of course, when you have the recurrence, you have to decide what to do. So that is a kind of poetry, and I think that is what is good for all neurosurgery, and is very important for the people that are dealing with gliomas, because we are driven by our patient, and everything else is the madness, as Pat Kelly showed before. Thank you for your attention.
Thank you, Professor Broggi, for that fantastic lecture. If I have to summarize the treatment of glioblastomas, we have been struggling to tame this monster for a long time. Every neurosurgeon agrees to one philosophy, that radical resection should be done. Some people think that more than radical resection or supra-radical resection is better. There are various ways and means to do this radical resection. The bottom line is, you see, this is a monster. Nobody knows that the radicality of resection indeed improves the long-term outcome. Nobody has ever been able to do that. But there is no question that radical resection should be done. The premise is that in the endeavor to do radical resection, we should never harm the person. If we try to do a little bit more than this, and we are, threatening the function of the person, that may be a very, very wrong surgery in this monstrous tumor. So safety, number one, is the bottom line. Safety, number one parameter. Second is radical resection, number two parameter. So making both these two parameters work simultaneously is the bottom line of our surgery for glioblastomas. Victor, for your comment. And then I will like to have comments of Dr. Takashi. And Takashi, yes. Victor, please go ahead.
Yeah, thank you.
Just one sentence to the presentation. I didn't talk about supramaximal, because what is high grade, and to do supramaximal resection in high grade is crazy.
Dr. Giovanni Broggi, thanks for this lecture. It was really interesting. We know that you have more than 50 years working in the field of neurosurgery, and you have also written more than 500 research articles about this field. Doing also functional brain surgery. So I just want to ask you one thing. What technique do you think is the most promising in this area of neurosurgery for high malignant tumors?
Well, I think that, as I said, intraoperative MRI is very difficult to have it, but the intraoperative ultrasound, the costal immediate, is easy to have it. Fluorescence system are helping us. I think that nevertheless, the technique is, of course, is inside, outside to take away the tumor, but neuromonitoring, physiological monitoring is quite important for the quality of life of the patient, both if the patient is awake or if the patient is asleep.
Okay, Takashi, can you give a comment?
Okay, thank you. I use 5R for glioma resections. So sometimes I experience a false positive one, a false negative one. Have you ever experienced a false positive during surgery or using fluorescence?
False positive.
Experience fluorescence.
No, as I showed, it was very fast. I show you that the experience of biopsy outside the boundaries.
Okay.
We say that we have sometimes you have to stop because the neurophysiology stop you, but we have never had a false positive to take out the tumor on the boundaries and to say it's safe.
Okay, Matthias, you have anything? Matthias? Imad, are we having...
Vladimir has some issues and Ibrahim.
Yeah.
Vladimir.
Yes, Vladimir, yes.
Yeah.
Pablo, you also keep yourself ready.
When 5-ALA started, the company selling it made a course for us. And the first and last thing they wanted was that we never ever resect the tumor during the ALA light on. On the other hand, I found it most helpful to scusa all the reddish tissue. What's your opinion about that? They prohibited it, but it's extremely helpful to use it during the resection. Resect under the light.
Well, if you resect under the light, the experience of the surgeon is very important. I suggest that when to use the ultrasound, the CUSA, or what you call it, in the core of the tumor. But when you go to the boundaries, it's much better to have a double suction. That means one slow, another one very heavy, because in this situation you may avoid the damage of the, let's say, perforator arteries around the tumors. The CUSA is killing them.
Pablo, you have something to say about glioblastomas and about ALA? Unmute.
Well, 5AL, I'm unmuted. Can you hear me?
Yes.
We are using it, let's say, routinely, in capital letters, I would say routinely. And the thing is that I'm quite surprised because sometimes we use the timing very sharp, 4 hours before what we expect to find the tumor there. And sometimes it's the fluorescence, the kind of fluorescence where you expect to have it very high. It's not so high. And sometimes when you are sure that this tissue is going to be healthy, let's say healthy, you get some fluorescence. So this is the main handicap I am finding. Otherwise, it has been quite useful in some points in which I could not find some hidden, let's say hidden corners, in which my view could not be clear and the tissue is not so clearly pathological, I found it very, very useful. So this is what I think. So this is why we are still using it.
You're using 5-hour? You're talking about 5-hour or fluorescence?
5-ILA, 5-ALA, yeah.
What I find that 5-LA is perfect for like a film remnant for the border of the tumor. But when you have a nodular tumor, then you may miss it. In that case, intra-op MR is the best. A combination of both these is extremely helpful. But Johnny, tell me, if you open the ventricle, always the walls of the ventricle are red. It always seems that it's a tumor. It never is.
Okay, what I will like to do is I will, Imad, is Dr. Tang ready or?
Well,
Doctor,
he was working on that.
Yeah, Victor.
Sorry. Dr. Ibrahim Zbeit is doing exercise with his right hand, but also I think he has a comment.
Yes,
Go
I
ahead,
do.
Dr. Ibrahim.
I started having the feeling that Atul is ignoring me completely. I don't know why.
No, I don't see you on the screen.
He is not having you on the screen, neither myself.
I'm joking. Giovanni, this is a very brilliant presentation. A lot of young neurosurgeons and residents are among the participants for this conference. There is a trend in the world as a whole, but more in the developing countries, for JBM to go for a biopsy and then send for radiotherapy. In my mind, my school of thought, this is a crime. What are words of wisdom that you'd like to give to those young people that radical excision of 80, 85%, 90% would help the following subsequent radiotherapy and chemotherapy? And for people to stop doing this bad, crazy practice of just taking a biopsy and send the patient for radiotherapy. I'd like your comments on that for the young generation.
I completely agree with you. I think the young generation have to learn to take out the tumors as much as possible. All the data show that the total resection or so-called subtotal resection is much better than just biopsy. Of course, you have to have the tools, but also in non-developed country, I think that the simple stimulation that you can use with bipolar stimulation can be help the young surgeon to do it. And if you have no fluorescence, use the ultrasound. I mean, ultrasound are in every hospital, they have ultrasound. So borrow the ultrasound and do it during the surgery. I think that's quite important. But you have to be taught to take out the tumors. Otherwise, we can close neurosurgery and go to radiotherapy. That's it.
Okay, Imad, you were saying something?
Yeah, I want to say we should depend on the clinical aspect. Many of these places, they don't have these fancy tools to do the guided resections. And I think the two messages given by a tool, two major messages. The number one is, of course, Karnofsky scale is essential. You won't operate on glioblastoma with somebody with a 40 or 50 Karnofsky in a deep-seated glioma, glioblastoma. This is number one. And number two, safety. If your resection is not going to improve his clinical condition at worsen it, it has no value. And I agree with Dr. Ibrahim, biopsy and radiation, this is the worst you can do. It's better not to touch it rather than to give them that morbidity of radiation on top of his biopsy, because the biopsy can break the balance and sometimes they go into severe edema, bleeding, and they were managing and then they got worse with the biopsy around. But clinically, this is important. Two factors should be considered when we take it in consideration.
May I add something? I am in a generation in which when I started, there was no neuronavigation. There was the finger. And the touch on the cortex, making you sure that that was a tumor. So we have to be ready to go back, because sometimes technology is broken down. And if you are in the middle of a surgery, what you have to do? Don't discourage you and go ahead. But I agree with you. quality of life is the goal, the first goal, as was said before, for any type of surgery on glioma, low grade, grade.
The other issue is, you see, the other issue is that when we leave some tumor behind, and when we do not leave any tumor behind, suppose there is a huge tumor, we leave behind 10% of tumor. Whether removing 100% is better or 10% leaving behind is worse, nobody in the world knows whether this tumor will recur or this tumor will not recur. But if you say, if you take just a biopsy, that of course is absolutely, radiology gives you information that it is glioblastoma. If you are taking biopsy, that is I don't want to use the word crime, but it is very close to that word. Now, Imad, what is happening to Tang?
Yeah, well, he sent me a message that he's trying. If he fails, then most probably I will put him first tomorrow morning on the schedule.
Okay.
I'm seeing here Dr. Kaspar. Welcome, Dr. Eckert. He's in the OR. He just joined. Do you have any comment? Most probably
Yeah, I just wanted to make one comment from Dr. Brodzi's statement about supramaximal resection and also resection in the low technology setting. So in tumors where the location of the GBM is in the temporal tip or the frontal tip, I actually take out the frontal lobe because there's no point in sparing a cortical rim that is just there for the recurrence. If you think about, most papers have focused on contrast enhancement and resect whatever is contrast enhancing. That's an outdated concept because Barker has shown that most tumor recurrences happen within 2 centimeters of a complete gross total resection. So if you have a chance to take out what's visible on FLAIR or take out the lobe the tumor resides in a temporal tip, just take out the temporal lobe, especially in the low technology setting, and you are much safer and you have not harmed the patient. And I think time for recurrence will be delayed.
Very good comment.
Thank you for this comment.
Can I have a comment on this? My father, who's now 99, was doing lobectomies for glioblastomas mostly, and the results were the same as now. Lobectomy. So it was more than supranational. Exactly what you are saying.
No, I disagree. I disagree. There's clearly a subgroup of patients where you take out the tumor in the lobe with all contrast enhancing, all FLAIR imaging in it, and they show profoundly later recurrences, not in the worst genetic subtype, but in all others. So I think it has blurred the image. I agree that historically data did not show that supramaximal resection helped, but if you find the right subgroup of patients, I think it does.
Okay, now I see Armando Basso on the screen, and I would like to have a very nice. Yes, Dr. Broggi, we have Armando.
I mean, one supramaximal resection. We have to remember Dandy was making a mesospherectomy, and the results were not so different of what we have today. The only advantage is that it is not easy to perform in the, let's say, not high technology country is the genetics, because if you have a guide on that, ADH1 positive or negative is changing the prognosis of the patient. So you can make a subtotal resection and after 15 days go ahead if the patient is less recurrence. But anyway, he will have in his life a recurrence.
Okay, so we have Armando Basso here, one of our very senior and
very
respected colleagues. Okay.
Thank you, Atul, for giving me the opportunity to say something. You know that in the last 40 years, we discuss in every meeting, every congress, everywhere, the problem of gliomas, low grade or high grade. The only answer that we have with that problem is that, of course, in the hands of a good surgeon, total removal of the tumor is the only true, but with unconditioned preservation of quality of patient or quality of life of the patient. In high-grade gliomas, in the best hands, we have the most 2 years survival. In the low-grade gliomas, we have in the best hands almost we can have 15 years survive, because then we have a recurrence, and when we have a recurrence, frequently we have a differentiation. A low-grade glioma became in the recurrence a high-grade glioma. So this is different. So I think has been demonstrated for good surgeons around the world, the School of Houston, Professor Yashagil, Professor Al-Mefti, that group, you, of course, Atul, that in good hands, total removal of the tumor is the answer. All depends the localization of the tumor, the age of the patient, and all those things. So, so that's my impression. Of course, if you have technology, it's better for the diagnosis. Ultrasound is good if you don't have intraoperative MRI, etc., etc.
There is one question here, just a minute. There is one question on the question box about the corpus callosum butterfly gliomas. Now, can the, Professor Broggi, just one small answer, can you give me a small answer on butterfly gliomas? What is your protocol?
Well, if you're talking about the butterfly gliomas, you can take out the part in the non-dominant hemisphere. And sometimes you can take out also the other one. The only problem is that it depends on the psychological situation of the patient. You have still valid or not, because anyhow, if you touch the fornix, if you touch the septum, you will have a psychological deficit, and you have to know that. So be very careful.
No, Imad, sorry, it was a mistake. I must leave now, and I have sent you a message, but.
Okay, so Imad, Dr. Tang will speak tomorrow or today? What is the
No,
scene?
he is with us. He is with us. If we can give him the chance to give his presentation. Yes.
Okay,
Go
we'll
ahead.
be very, very happy to. There are some questions on the question box.
I think the speakers will take care of it.
I will
or
like the
yourself.
speakers to just answer, Dr. Broggi, just answer on the question box. And
Yes,
I'm very, very keen
will
to listen to Dr. Tang, my dear Dr. Tang from Beijing. Go ahead. You shouldn't, we are waiting to hear from you, Professor Tang.
Hello, everyone. So you can hear me now?
Yes, very good.
Okay,
Very good.
thank you. Sorry for my mistakes or something went wrong. So I continue to talk about the brainstem surgeries. Okay. So this is my institution now. So the brainstems, the glioma is distributed in the different the age group is quite common in childhood, but it's very rare in the adult. Unfortunately, it's about 80% is the DIPG. We talk a lot about this. Is unaccessible for the surgery, but it's indication for biopsy, followed by the radiation. Another about the rest, about the 20% is exophytic, is focal, the lesions. This kind is indicated for the surgery. But we should know the biology about the tumors. For example, the tumors in tactile, the glioma, and also the glioma in the gangliogliomas is a very benign tumors. So for this kind of the lesion, I think resection maybe not the first choice, maybe the VP shunt or the third ventriculostomy is the preferred. Okay. So this is a very good summary about the principle of the surgery for the brainstem lesions, the 2-point method, and also the safe entry zoom. It's mentioned a lot in the arbitrarian. But before, in addition to this, I think now we have the high technology to learn about the structures, the fibers, and the nucleus. So the image guide technology is very important, and also the monitoring. Monitoring sometimes is mandatory for preserve the function of the brainstem for the cranial nerve, but sometimes it's not so important one, I think. It depends on the location of the lesion. And also for the outcomes, the post-operative is also very crucial for the outcome. Otherwise, if the patient have the difficult with breathe or some the difficult for the swallow, is the disaster postoperatively. And also this very beautiful the drawings to show the SIP entry zones in the brain stems. And also in the midbrain, we have the anterior and the posterior have this the SIP entry zones. But this is only for the focal lesions in the brainstem. For the exophatic, the lesions is no use with the SIP entry zones, I think. And also this is approach, it's well established for the SIP entry zones. And from the up to the lower for the middle brain, for the orbital zygomatic OZ approach for the anterior midbrain. And if we go for the posterior midbrain, we can use the occipital transtentorial, or we can use the supracerebellar infratentorial to reach the posterior part. For the lateral part about the midbrain, I recommended the subtemporal approach. So if we cut subtemporal with the transtentorial exposure, we can to reach the lower part of the pontine, and we can reach with the super trigeminal zone to reach the pontine. And we can, if we remove part of the anterior transpistosal, we can reach the lower between the trigeminal nerve. So just now Ibrahim Singh asked the questions whether superior is better or is in the inferior is better. I think it depends on the lesion inside of the pontines. This is quite established surgical approach and the SIP entry zones. For the posterior part of brain stems, also we have the sub-occipital midlines, or the sub-occipital cerebellar approach to reach the posterior side of the brain stems. And this is a very beautiful drawing to show the summarize the approach to reach the regions of the brain stems. And we can see from the anterior part of the midbrain, the orbital zygomatic approach can reach this area. And also here, this is anterior methylic zone. It's just laterally to the oculomotor nerve and to the size of the cerebral spinal tract from this to reach the lesion. So this picture is of this photo is for the cavernous malformation, but it is also I think suitable for the focal lesions like a glioma is in this area. And for the subtemporal approach, some of the others insist is only for the lateral side or for the midbrain, but I think it's quite we can use it quite often to expose much lower the wide with the transtentorial. We can reach from the midbrain to the trigeminal the regions, and if we remove part of the anterior transpistosal, we can reach much lower part of this. So this area is some overlap with a retrosigmoid approach. To reach this is super trigeminal the zone, or is the para trigeminal the zone. And also from the retrosigmoid approach, also we can expose the whole pontine the areas. And this is for lateral for the anterior and the lateral for the medullas. And this suboccipital, we can expose the whole the posterior side about from the pontine to the medulla. And this is a case is about the midbrain glioma in the posterior part of the midbrain. So this is 41 years old, suffer from the mild headache, and there's a lesion in the brainstem in the midbrain first part is with a very mild enhancement. So for this case, in the local hospital, just recommended observe because the local doctors concerned about the risk of the surgery resections. And after 12 years, the patient is still have the headache, and the repeated MRI to show the lesion in this brainstem is enlarged with systemic formation. So it performed the VP shunt in the local hospital and no other neurological deficit. Another 5 years later, the tumor enlarged, and also the patient have some the mild the symptom, and one came to our hospital. We did the resection through the occipital transtentorial approach to remove this lesion. The patient recovered very well and lived a very independent life up to now, and there's no recurrence after the 5 years follow-up. So for this case, I think for the pathology is pilocytic tumors. For this kind of the lesion, for me, for the doctors with concern about the risk of the surgery, I recommend the VP shunt first, and we can refer this patient maybe to the senior doctor to do the operation for the safeties. And also for the posterior part of the midbrain, there's the two approach. One is occipital transtentorial approach, is above the tentorium. Another is the infratentorium, supracerebellar approach. And all this approach is go beneath, under the wings. It's not above, it's beneath, it's under the wing, the Galen, the wing of Galen. So for me, I'm more familiar with the occipital transtentorial. I think it's much safe. And also we can expose the lateral perspective, lateral side about the midbrain. So this is Rotten's book is very beautiful the photos to show the approach. One is occipital transtentorial, another is under the tentorium. We can see there's a lot of this two tentorium, and we go this beneath the wings to reach the posterior side of the midbrain. And all this, the occipital transtentorium approach, I think this is much comfortable for surgeons. But here we should cut the tentorium under the straight signers and expose the posterior part of the midbrain. And here we don't retract the wing downward. We should lift. We do this is under the wing, not retract the wing. And for the anterior part of the midbrain, we have mentioned a lot of orbitodigomatic approach, but I don't think this is quite rare, and we can to reach this approach in very, very narrow space. It's quite challenging for our practice. And the subtemporal approach, I have mentioned this in last our course, is a very wild. We can use the in many cases, in many situations, to expose up to the midbrain and lower to the trigeminal, this area, to subtemporal approach with a transtentorium and with some removal of the anterior transpetrosal approach. And this is a subtemporal approach, and this is the view from the subtemporal approach. This is, I think, from the lateral of the midbrain is exposed very widely, and we can see the trochlear nerve, and this is the lateral mesencephalic sulcus. It's very easy to expose. But here, on this photo to show, we can see even the anterior side of the approach. But I don't think subtemporal approach we can expose so anteriorly. Normally, we can expose this lateral part about the midbrain. And this to show the standard subtemporal approach, we can expose the lateral, the midbrain with the transtentorial extension. We can have a more lower, and with the anterior transpetrosal removal, we can reach much lower about the brainstem, even the lower than the trigeminal nerve. And this is the under the trigeminal, and this is superior to the trigeminal to expose. For this case, this is a young kid suffer from the weakness. And from the lesion, from MRI, routine MRI, we can see from the enhancement. Initially, maybe we consider this is a malignant tumor, but this boy suffered this mild weakness for 1 year. And this leaders to think maybe this is a benign tumor. And based on this DTI, the information, we do the preoperative the selection about the surgical approach to avoid the damage to the brain, the tissue, the fibers. So at this, from this the lesion, we cannot know the safe entry zone because the normal structure was distorted by the lesions. And we use the subtemporal approach and selected a way to remove the lesion and to remove the tumor totally. And this is below the trigeminal and above the trigeminal nerve. And also intraoperatively, we use the bipolar for the monitoring, the stimulation to keep to do some the monitoring. And after the operation, the boy recovered very well. And we can see there's no the neurological deficit. So this is now our the understanding about the brainstem and also the neuroimaging to bring us the good outcome. Even 5 years after the boy is very well. So the pathology is also the pilocytic astrocytoma. For the medullary, this area I think is we should pay attention to this to the alvex. And also the vagus triangle is very close to the alvex because the vagal triangle is associated with postoperative airway obstructions, and alvex is related to the breath, the simultaneous breath. So we should do this very, very gently, and also intraoperatively. If the maneuver is close to the vagal triangle, maybe the heartbreak will drop to 0. And we should have a very good collaboration with the anesthetist. And for this case, for the posterior lateral approach, we just use a occipital televelar approach. We lift the cerebellum very gently and remove the lesion totally. And for this kind of the lesion is anterior laterally, we use the bilateral approach and to remove this tumor totally and gently. And also we use the monitoring and also the fiber tracking to do the postoperative operative plan, and also to do the monitoring for the evaluation about the function postoperative. So this the new technology to help us to understand the structures inside of the brain with the lesion inside, all the after because of the tumor push these fibers away. This new technology to enhance our ability to remove the tumors safely, not only in these schematic drawings, and we can see from this very fine the pictures, we can know this the fibers in vivals, how does this the fiber goes and how our the approach may affect these fibers and these structures. So before I finish, I want to say the brainstem is still challenging for us to receive, but with our understanding and the new technology, we can have a good outcome. Thank you for your attention.
Thank you, Dr. Tang, for this wonderful, beautiful lecture and beautiful hospital like Sami's hospital, INI. This is like INI, right? INI Beijing?
Yeah, this is INI in Beijing.
Yeah, this looks very, very fantastic.
Yeah,
yes.
Welcome in the future.
Thank you.
Welcome to have you. And
yes,
my office is here. The lighting is here.
Oh, you have put a light there, right?
To take the photo.
That is the safe entry zone.
Yes.
Yes, Imad, for your comments, please.
Yes, I think we are 1 hour over time. I think the question will leave that for the speakers to answer all questions on chat according to their topics. I'd like to thank all the speakers and the faculties for their fantastic presentation. Needless to say that Atul has given us an additional 1 hour of work, but he gave a flavor and zest to the discussion. We appreciate that. We appreciate all the new faculties that they presented today and the standard, the group that they are always with us, the team, the family. And I think tomorrow we will start 12 Greenwich Mean Time. I hope tomorrow we'll finish on time. We'll be on the intraventricular lesions and ventricular anatomy. Will be another exciting and successful one like today. For people who look searching for the certificate, they should send their email or the registration, which is a free registration, and give their feedback, and they will get the certificate. I think Vladimir has excused himself, and he gave his regards to every one of you. I'd like to thank all the moderators of the sessions, and I apologize for this one that they were excused by going to surgery. Thanks, Atul, again, and thanks everybody, and see you tomorrow. Good night.
Thank you. Thank you.
Bye.
Good
Thank
night.
you.
Good night.
Hey, good night.
Bye-bye.
Thank you.
Good night.
Thank you. Good night.
Thank
Thank
you.
you. Good night.
Professor Giovanni, thank you.
Bye-bye, Tom.
Thank you. Very interesting. See
Bye,
you tomorrow.
Bye-bye.
Buddy,
Bye.
Dr. Kohn,
Bye,
Hey,
guys.
thank
Bye.
you.
Dr. Jitang, you manage, and
Thank you.
Giovanni.
Thank you for
Very
Oh,
enjoyable.
here,
Good.
IP
See you
is in the
tomorrow.
dark. IP in the dark. I saw him just.
Yeah.
IP, good night.
Good night. Good night,
Guys, good
everybody.
night.
Bye-bye.
Night.
Bye-bye.
Good night, everybody. Bye.